Tonight we are going to talk about a small machine that left home 54 years ago and never came back. It weighs about as much as a grand piano. It carries no fuel, no working instruments, nothing that hums or blinks or dreams. It is roughly the size of a dishwasher if you do not count the long golden arms of its antenna dish, and it is farther from Earth tonight than any object we have ever made, farther than any object we will ever touch again. Its name is Pioneer 10, and it was the first spacecraft to cross the asteroid belt, the first to visit Jupiter, the first to leave the inner solar system entirely, and the first to carry a message intended not for us, but for whoever might find it drifting through the galaxy long after the civilization that built it has become unrecognizable or gone. What would it see if it looked back? What would it hear? Is there anything out there at all in the direction it is travelling, or is it sailing into a darkness so complete that even the word darkness seems too generous? And what does it mean that we sent it anyway? That we attached a golden portrait of ourselves to its side and pushed it gently toward a star it will not reach for 2 million years, knowing that no one alive today would ever learn whether the message was received. By the end of tonight, you are going to understand exactly where Pioneer 10 is right now, what surrounds it in the deep black between stars, and why the truth about its journey is far stranger and more quietly beautiful than you might expect. You're going to meet the people who built it, the engineer who designed its famous plaque, and the small team of faithful listeners who tracked its whisper across the solar system for more than 3 decades, until even that whisper fell silent. And you're going to sit with a question that has no comfortable answer, a question about what it means to send something out into the universe with no hope of reply, and whether that act is a kind of faith, or a kind of letting go, or something else entirely that we do not yet have a word for. Before we get started, if you love exploring the depths of space and time as much as we do, take a second to like the video or subscribe. It is a simple action, but it helps this channel reach more curious minds like yours. Now let us begin. The story starts in a place that no longer exists, not because it was destroyed, but because the world around it changed so completely that walking through those same corridors today would feel like visiting a foreign country that happens to share a name with your hometown. It was the summer of 1972. The war in Vietnam was still grinding on. The Watergate break-in had just occurred, though no one yet understood what it would become. Richard Nixon was president. The pocket calculator was a novelty item that cost as much as a week's wages. There were no personal computers, no internet, no mobile phones, no GPS satellites circling overhead to tell you where you were. The world that built Pioneer 10 was a world that still sent telegrams, that still measured long distances by how many days it took to drive them, that still thought of the solar system as a place we might visit someday, rather than a neighbourhood we'd begun to map. And yet, in a cluster of low, beige buildings on the edge of Mountain View, California, a small group of engineers and scientists was preparing to do something that had never been done before. They were going to throw a machine across the asteroid belt, that vast ring of tumbling rock and dust between Mars and Jupiter, and see if it survived. No one had ever tried this. The conventional wisdom held that the asteroid belt was too dense, too chaotic, too full of debris to cross safely. Some models suggested that any spacecraft attempting the passage would be sandblasted into silence within weeks. Others were more optimistic, but even the optimists hedged their predictions. The truth was that no one really knew what was out there. The belt had been observed only from a distance, its population of rocks inferred from the occasional glint of reflected sunlight and the mathematics of orbital mechanics. Sending Pioneer 10 through it was, in the most literal sense, a leap into the dark. The spacecraft itself was modest by the standards of what would come later. It was built by TRW Systems under contract to NASA's Ames Research Center, and it was designed to be simple, robust, and light. Its body was a hexagonal box about 2 feet deep, wrapped in thermal blankets to protect it from the cold of deep space. Extending from this box was a dish antenna 9 feet across, made of aluminum honeycomb so thin it weighed only about 30 pounds, and this dish would become the spacecraft's voice, the only way it could speak to Earth across the unimaginable distances it was about to cross. Mounted on long booms to keep them away from the spacecraft's own radiation were a handful of instruments: a magnetometer to measure magnetic fields, a plasma analyzer to sample the solar wind, a charged particle detector, a cosmic ray telescope, an ultraviolet photometer, and an imaging photopolarimeter that could, if all went well, build up pictures of Jupiter one narrow strip at a time as the spacecraft flew past. But the most important thing about Pioneer 10 was not what it carried, it was how little it needed. The spacecraft ran on 4 radioisotope thermoelectric generators, small cylinders filled with plutonium-238, a radioactive isotope that decays slowly and steadily, giving off heat that can be converted into electricity. At launch, these generators produced about 155 watts of power, less than the bulb in a bright reading lamp. And because plutonium decays, that power would fade by about 4 watts per year, a slow leak that the mission planners knew would eventually reduce the spacecraft to silence. They designed Pioneer 10 to operate for 21 months. That was the official mission duration. 21 months. Just long enough to cross the asteroid belt, swing past Jupiter, and send back what data it could before its power faded below the threshold needed to maintain communication. No one expected it to last much longer than that. No one imagined it would still be talking to Earth 31 years later, its voice grown so faint that only the largest radio telescopes on the planet could hear it. The man who oversaw the construction of Pioneer 10 was a NASA engineer named Charles Hall. He was not a famous figure, not then and not now. He did not give many interviews, he did not write memoirs, but everyone who worked with him remembered his patience, his attention to detail, and his gift for keeping a complicated project on schedule without crushing the spirit of the people involved. Hall understood that building a spacecraft is not like building a bridge or a car. You cannot test it in the real environment until it is too late to fix anything. You cannot retrieve it if something goes wrong. Every decision you make is final the moment the rocket clears the tower, and so every decision must be made with a kind of humility, an awareness that the universe is full of ways to surprise you, and that the best you can do is build something sturdy and hope it holds. The launch was scheduled for March of 1972. The rocket was an Atlas Centaur, a 2-stage vehicle that had been flying since 1963, topped by a solid-fuel third stage called the TE-3644 that would give Pioneer 10 the final kick it needed to escape Earth's gravity and begin its long fall toward Jupiter. On the night before launch, the spacecraft sat in its payload fairing at Cape Canaveral, wrapped in thermal blankets, its instruments powered down, its antenna folded against its body like the wing of a sleeping bird. The technicians had done everything they could. The trajectory had been calculated and recalculated. The software had been checked and double-checked. All that remained was to light the fuse and see what happened. At 9:49 in the evening, Eastern Standard Time on March 2nd, 1972, the Atlas engines ignited. A pillar of orange fire bloomed beneath the rocket, and Pioneer 10 rose into the Florida night, climbing faster and faster until it was just a point of light against the stars. 3 minutes later, the Atlas stage fell away. 6 minutes after that, the Centaur stage shut down, leaving the spacecraft coasting in Earth orbit while the flight controllers verified that all systems were functioning. And then, at 10:15, the third stage fired, a short, violent burn that accelerated Pioneer 10 to more than 32,000 miles per hour, the fastest any human-made object had ever travelled. It was the fastest, but it would not remain so for long. Within hours, Earth's gravity began to slow it down, clawing at the spacecraft as it climbed out of the planet's gravity well. By the end of the first day, Pioneer 10 had slowed to about 25,000 miles per hour. By the end of the first week, it had slowed further still, but it did not need to be fast anymore. It had already escaped. The mathematics of orbital mechanics had taken over, and now the spacecraft was falling outward, falling toward Jupiter, falling along a long curving arc that would take it across the inner solar system and into the asteroid belt by the middle of July. The crossing of the asteroid belt lasted 7 months. For most of that time, nothing happened. The spacecraft coasted in silence, its instruments sampling the thin plasma of the solar wind, its antenna pointed back toward the small blue world it had left behind. The meteoroid detectors registered a few impacts, tiny grains of dust striking the spacecraft at high speed, but nothing catastrophic. The feared sandstorm never materialized. The asteroid belt, it turned out, was far emptier than anyone had expected. The rocks were there, millions of them, but they were scattered across such an enormous volume of space that the odds of hitting one were vanishingly small. Pioneer 10 slipped through the belt like a fish through water, barely noticing its passage, and by February of 1973 it had emerged on the other side, intact and still talking, still sending its faint whisper back to the dishes on Earth. But the asteroid belt was only the first test. The real destination was still ahead. Jupiter is difficult to describe without resorting to numbers, and numbers, spoken aloud, rarely convey the feeling of a thing. So instead of telling you that Jupiter is 11 times wider than Earth, let me ask you to imagine something. Imagine standing on a beach at night looking out at the ocean. The water is black, and the horizon is invisible, and all you can see is the faint line where the stars meet the sea. Now imagine that the ocean begins to rise, slowly at first, then faster, a wall of black water climbing into the sky, blocking out the stars one by one, filling your entire field of vision until there is nothing left but darkness and the sense of something vast and heavy pressing down on you from above. That is what it would feel like to approach Jupiter. The planet is so large that it would fill your sky long before you reached it. You would see it growing, day after day, from a bright point to a disk to a wall to a world that swallowed everything else, and you would feel, in some primitive part of your brain, the wrongness of it, the sense that something that big should not exist, that the universe has no business making planets on that scale. Pioneer 10 did not feel this, of course. It had no eyes, no brain, no nervous system to register awe or fear. But the instruments it carried were about to encounter something that would test them to their limits. Jupiter is not just large, it is violent. The planet is wrapped in radiation belts so intense that a human being standing on one of its inner moons would receive a lethal dose within minutes. Charged particles, protons and electrons accelerated to enormous energies by Jupiter's spinning magnetic field, fill the space around the planet in a seething invisible storm. No one knew, before Pioneer 10, exactly how intense these radiation belts were. The estimates varied by orders of magnitude. Some scientists thought the spacecraft might survive a close flyby. Others thought it would be fried before it ever reached closest approach. The mission planners chose a trajectory that would bring Pioneer 10 within about 81,000 miles of Jupiter's cloud tops, close enough to get good data, far enough to give the spacecraft a fighting chance. But even this cautious approach was a gamble. The radiation environment near Jupiter was unknown territory. The only way to learn what was out there was to fly through it and see what survived. On December 3rd, 1973, Pioneer 10 made its closest approach to Jupiter. The spacecraft had been travelling for 21 months. It was now more than 500 million miles from Earth, farther than any spacecraft had ever been, and it was about to do something no machine had ever done: look at Jupiter up close. The imaging photopolarimeter began its work. This was not a camera in the modern sense. It did not take snapshots. Instead, it scanned the planet one narrow strip at a time, building up images line by line as the spacecraft rotated, like a fax machine receiving a photograph from across the solar system. The process was slow and painstaking. Each image took hours to assemble. But when the images finally arrived at Earth, they revealed a world more beautiful and more terrifying than anyone had imagined. The Great Red Spot was there, of course, that ancient storm wider than the Earth, spinning in the southern hemisphere like a slow whirlpool in an ocean of ammonia clouds. But there was so much more. There were bands of colour stretching around the planet, shades of orange and brown and cream swirling into one another in patterns that seemed almost organic, almost alive. There were smaller storms, white ovals and brown barges churning through the atmosphere at hundreds of miles per hour. There were shadows cast by the moons, perfect black circles moving across the cloud tops. And there was a sense of depth, a sense that the clouds were not just painted on the surface but extended down and down into an atmosphere so thick and so deep that it eventually became something that was no longer gas, something that was not quite liquid, something for which we have no good name. The instruments recorded everything. The magnetometer measured Jupiter's magnetic field, which turned out to be 20,000 times stronger than Earth's, powerful enough to carve out a bubble in the solar wind that extended millions of miles in every direction. The charged particle detectors registered the radiation, which was far more intense than the worst-case predictions. Intense enough that several instruments briefly malfunctioned, their circuits scrambled by the flood of high-energy particles. The plasma analyzer sampled the thin hot gas trapped in the magnetic field. The cosmic ray telescope counted particles that had come not from Jupiter, but from beyond the solar system, interstellar travellers that had been deflected by the planet's immense magnetic presence. And then, almost as quickly as it had arrived, Pioneer 10 was past. The gravitational encounter with Jupiter had accelerated the spacecraft by more than 20,000 miles per hour, a boost provided for free by the planet's motion around the Sun, a trick of orbital mechanics that we call a gravity assist. This boost was enough to change everything. Before Jupiter, Pioneer 10 had been bound to the solar system, following an orbit that would have kept it circling the Sun forever, never straying much farther than the orbit of Neptune. After Jupiter, Pioneer 10 was free. Its velocity now exceeded the escape velocity of the Sun itself. It would never come back. It would coast outward forever, slowing gradually as the Sun's gravity tugged at it from behind, but never slowing enough to stop. The first chapter of its journey was over. The second chapter, the one that would last for eternity, had just begun. In the months that followed the Jupiter encounter, the mission team at Ames Research Center found themselves in an unusual position. They had built a spacecraft for a 21-month mission, and the mission had succeeded beyond all expectations. Pioneer 10 was still functioning, still returning data, still talking to Earth across a distance that grew larger every day. What were they supposed to do now? The answer, it turned out, was simple: keep listening. And so they did. Year after year, the team tracked Pioneer 10 as it climbed outward through the solar system. It passed the orbit of Saturn in 1976. It passed the orbit of Uranus in 1979. It passed the orbit of Neptune in 1983. And with that passage, it became the most distant human-made object in existence, a title it would hold for more than a decade, until its twin, Pioneer 11, and later the Voyager spacecraft, caught up and passed it on trajectories of their own. But the distance alone was not what made Pioneer 10 remarkable. What made it remarkable was that it refused to die. The plutonium in its generators decayed year after year, and the power faded watt by slow watt. The engineers on Earth watched the telemetry and calculated how much longer the spacecraft could survive. They turned off instruments one by one to conserve power. They reduced the data rate to a trickle. They did everything they could to extend the mission, to squeeze one more year, one more month, one more week out of the fading heartbeat of that distant machine. And Pioneer 10 kept talking. The signal it sent was impossibly weak. By the time it reached Earth, it had spread out over such an enormous volume of space that the power received by the largest radio telescopes was measured in watts times 10 to the negative 21st, a number so small that it has no meaningful comparison in everyday life. If you collected that signal for 1 billion years, you would not have enough energy to lift a single grain of sand. And yet the Deep Space Network heard it. The 70-meter dishes at Goldstone and Canberra and Madrid turned their patient ears toward the constellation Taurus, and they listened, and they heard the whisper of a spacecraft that should have fallen silent decades ago. The last successful contact with Pioneer 10 came on January 23, 2003. The spacecraft was then about 7.5 billion miles from Earth, more than 80 times the distance from the Earth to the Sun. The signal took 11 hours and 20 minutes to cross that gulf, 11 hours to travel from the spacecraft to the dish, and another 11 hours for any response to travel back. The data returned was fragmentary. The spacecraft's power had dropped so low that only the most essential systems were still functioning, but it was enough. It was proof that Pioneer 10 was still out there, still coasting, still carrying its message into the dark. A few weeks later, the team at Ames tried again. This time, there was no response. The signal, if it came at all, was too weak to detect. The whisper had faded below the threshold of hearing. And so, after 31 years, the conversation ended. But the journey did not. There is a photograph that was taken in 1972, a few weeks before launch, in a clean room at the TRW facility in Redondo Beach. It shows the Pioneer 10 spacecraft mounted on a test stand, its golden antenna dish gleaming under the fluorescent lights, its body wrapped in the thermal blankets that would protect it from the cold of deep space. Standing next to it, dwarfed by the dish, is a small group of engineers in white smocks and hairnets, their faces a mixture of pride and exhaustion, and something else. Something harder to name. They had spent years building this machine. They had solved problems that no one had ever faced before. They had argued and compromised and stayed late and come in early and done all the small, unglamorous work that turns a blueprint into a spacecraft. And now it was finished, and in a few weeks it would be gone. launched toward a planet so far away that light itself took 40 minutes to make the journey. One of the people in that photograph was a man named Carl Sagan. Sagan was not an engineer. He was a planetary scientist, a professor at Cornell, a man with an unusual gift for explaining complicated ideas in language that ordinary people could understand. He had been involved with the Pioneer missions from the beginning, serving as a member of the imaging team, helping to plan the observations that would be made during the Jupiter flyby. But in the fall of 1971, Sagan had an idea that had nothing to do with science. He realized that Pioneer 10 was going to leave the solar system. This was not a secret. The trajectory had been calculated, the physics was clear, everyone knew that the spacecraft would eventually escape the sun's gravity and drift into interstellar space. But Sagan was the first to ask a question that, in retrospect, seems obvious. If this spacecraft is going to travel for millions of years, shouldn't it carry something? Shouldn't it carry a message? The idea was not practical in any conventional sense. The odds that Pioneer 10 would ever be found by another civilization were astronomically small, smaller perhaps than any odds that have ever been calculated. Space is too vast, the distance is too great, the darkness too complete. A spacecraft the size of a dishwasher, coasting through the galaxy at 30,000 miles per hour, is not going to be noticed by anyone. It will pass through the emptiness between stars like a grain of sand sinking through the Mariana Trench, invisible, untraceable, alone. And yet there is something in the human spirit that cannot resist the gesture. We write letters we know will never be read. We throw bottles into the ocean even when we know the currents will carry them nowhere. We speak to the dead, we pray to gods we cannot prove exist. We send our voices out into the silence because the alternative, to say nothing, to let the silence remain unbroken, feels like a kind of surrender. Sagan understood this. He understood that the message was not really for whoever might find it. The message was for us. It was a way of saying that we are here, that we exist, that we have looked up at the stars and wondered what was out there, and that we cared enough to answer our own question, even when we knew no answer would ever come. And so, with less than 3 months until launch, Sagan set about designing a plaque that would be attached to the side of Pioneer 10, a small golden rectangle 6 inches by 9 inches that would carry a portrait of humanity into the dark. He did not work alone. His wife at the time, the artist and writer Linda Salzman Sagan, drew the figures, a man and a woman standing side by side, the man's hand raised in what was intended as a gesture of greeting. The figures were nude, a choice that later caused some controversy, but that Sagan defended as the most honest representation of what human beings actually look like. Behind them, in simple line drawings, were symbols that any civilization with a knowledge of physics should be able to decode. A diagram of the hydrogen atom, the most common element in the universe, with a symbol indicating the frequency of the radio waves it emits when its electron changes energy states. A starburst of lines showing the position of the sun relative to 14 pulsars, those spinning neutron stars that broadcast their locations like cosmic lighthouses. A diagram of the solar system with a small arrow showing where Pioneer 10 came from, and at the bottom, a schematic of the spacecraft itself, drawn to scale against the human figures so that whoever found it would know how big we are. The plaque was finished in 3 weeks. It was etched into a sheet of gold anodized aluminum, chosen because gold does not corrode and because the lines would remain legible for billions of years in the vacuum of space. On February 25, 1972, the plaque was bolted to the antenna support struts of Pioneer 10, where it would be shielded from the micrometeorites and cosmic rays that might erode its surface during the long journey ahead. And there it remains tonight, 54 years later, still attached to a spacecraft that no one has heard from in more than 2 decades, still carrying its portrait of humanity toward a star it will not reach for 2 million years. Spare a thought for what that plaque has endured. It has travelled through the radiation belts of Jupiter, bombarded by particles that would kill a human being in minutes. It has felt the temperature drop as Pioneer 10 climbed away from the sun, falling from the warmth of Earth's neighbourhood to the bitter cold of the outer solar system, where the sunlight is so faint that it barely warms the spacecraft above the background chill of space itself. It has been alone, utterly, completely alone, for longer than many human civilizations have existed. The Egyptian pyramids are younger than Pioneer 10's silence. The Roman Empire rose and fell in less time than Pioneer 10 has been coasting through the dark. And still the plaque waits. It waits for something that will almost certainly never come. A hand, a sensor, a moment of recognition. It waits in the same way that a love letter waits in a drawer, or a message in a bottle waits on a beach, or a prayer waits in the silence after it has been spoken. It waits not because it expects an answer, but because the waiting is itself the point. We sent it because we are the kind of creatures who send things. We sent it because the universe is vast and cold and silent, and we wanted to say that we were here, that we mattered, that we looked up and wondered and cared. If Pioneer 10 could feel, and of course it cannot, perhaps it would understand this. Perhaps it would know that the plaque on its side is not a practical communication, but a kind of love letter, written by a species that was afraid of the dark and sent a small machine out into it anyway, just to prove that the darkness could be crossed. The distance that Pioneer 10 has travelled is difficult to hold in the mind. We have words for it. Billions of miles, light hours, astronomical units. But words are not the same as understanding, so let me try a different approach. Imagine that you are standing on the Earth, looking up at the Sun. The Sun is about 93 million miles away. Light, which travels faster than anything else in the universe, takes about 8 minutes to cross that distance. When you look at the Sun, you're seeing it as it was 8 minutes ago. This is a small delay, barely noticeable in human terms, but it is already a reminder that the universe is not as immediate as it seems. Now imagine Pioneer 10. As of tonight, the spacecraft is roughly 15 billion miles from Earth. That is more than 160 times the distance from the Earth to the Sun. Light from Pioneer 10, if it were sending any, would take more than 22 hours to reach us. A radio signal sent from Earth, travelling at the speed of light, would take 22 hours to arrive at the spacecraft, and another 22 hours to return, a round-trip time of nearly 2 days just to say hello and hear the answer. But even this does not capture the strangeness of where Pioneer 10 is now. The spacecraft is not just far away in space, it is far away in a specific direction, climbing out of the solar system along a trajectory that will carry it toward the constellation Taurus, toward a red giant star called Aldebaran that burns 65 light-years from the Sun. At its current speed, Pioneer 10 will not reach the neighbourhood of Aldebaran for about 2 million years, and by then, Aldebaran will have moved, carried along by its own motion through the galaxy, and Pioneer 10 will drift past it at a distance of a few light-years, close by the standards of interstellar space but still impossibly far by any human measure. 2 million years. The number is so large that it resists comprehension. 2 million years ago, our ancestors were not yet human. They walked upright. They used simple tools, but they did not yet have language, or fire, or the capacity for abstract thought that would eventually lead them to build spacecraft and send them to the stars. 2 million years from now, if humanity still exists in any recognizable form, we will have become something so different from what we are today that Pioneer 10's plaque may be as mysterious to our descendants as a cave painting is to us. And yet Pioneer 10 will still be coasting, still carrying its message, still falling through the dark. This is what it means to send something into interstellar space. It is not like sending a letter across the ocean, or even like sending a spacecraft to Mars. It is like dropping a pebble into a well, so deep that you will never hear it hit the bottom. The pebble falls, and falls, and falls, and you walk away, and your children walk away, and their children walk away, and still the pebble falls. It becomes a story, then a legend, then a myth, and still it falls. And somewhere, in the unimaginable future, it finally comes to rest, not with a splash, not with a sound, but in silence, in darkness, in a place that no one will ever see. Pioneer 10 is that pebble. We dropped it into the well in 1972, and we listened to it fall for 31 years, and then the sound faded below the threshold of hearing, and now we can only imagine where it is and what surrounds it as it continues its endless descent. What does surround it? What is out there, in the space between stars, where Pioneer 10 is travelling tonight? The answer, perhaps surprisingly, is not nothing. It is almost nothing. A near vacuum so empty that it makes the best laboratory vacuum on Earth look as thick as honey. But it is not quite nothing. There are a few atoms per cubic centimetre, mostly hydrogen, the primordial element left over from the Big Bang. There are grains of dust scattered so thinly that Pioneer 10 might travel for centuries without encountering one. There are cosmic rays, high-energy particles that have been accelerated by distant supernovae and are now crisscrossing the galaxy at nearly the speed of light. There is the faint glow of starlight, the combined radiance of 100 billion suns, diffused and diluted by the vast distances of space until it is barely brighter than the darkness itself. And there is cold. The temperature in interstellar space is about 2.7 degrees above absolute zero, the faint warmth left over from the Big Bang itself, a cosmic background radiation that fills the entire universe and will never go away. Pioneer 10 is bathed in this cold, and it has been bathed in it for decades, and it will be bathed in it forever. The spacecraft's thermal blankets have long since cooled to the ambient temperature of space. The plutonium in its generators has decayed beyond the point where it can produce useful power. If there is any warmth left in Pioneer 10 at all, it is the warmth of radioactive decay, a faint trickle of heat that will take thousands of years to fade completely. The spacecraft is not dead exactly. It is dormant. It is coasting. It is doing what it was designed to do: travel through space, carry its message, endure, but it is doing it in silence, without instruments, without communication, without any way to tell us that it is still there. And so, we are left to imagine. We are left to calculate where it must be, based on the last known position and the laws of physics, and to picture it in our minds as it continues its journey into the dark. It is a strange kind of companionship, this relationship between humanity and a spacecraft we can no longer hear. We know it is out there. We know it carries our portrait, our greeting, our hope. We know it will outlast us, outlast our civilization, outlast perhaps the Earth itself. And we know that it does not know any of this. It is just a machine, a collection of metal and wire and plutonium following a trajectory that was calculated 54 years ago. It has no sense of its own significance. It has no awareness of the message it carries. It is faithful only in the way that a river is faithful to its course, because there is no other way for it to be. But faithfulness, even when it is unconscious, even when it is merely the result of physics, is still a kind of gift. Pioneer 10 is faithful to its mission. It is faithful to the trajectory we gave it. It is faithful to the act of travelling, of carrying, of enduring. And in its faithfulness there is something that feels almost like devotion. We tend to something that cannot thank us. We track something that cannot call back. We remember something that cannot remember us. And in doing so, we become part of a story that is larger than ourselves, a story that will continue long after we're gone. And so let us stay with that word for a moment, devotion, because it is the right word, even if it seems strange to use it for a machine. Devotion implies intention, implies choice, implies the warmth of a heart that decides again and again to keep faith with something it loves. And Pioneer 10 has none of these things. It has no heart, no intention, no capacity to choose. It is simply moving, obeying the laws that govern all matter, following the curve of space that was imparted to it half a century ago by a rocket engine that burned for a few minutes and then fell silent forever. But devotion, in its deepest sense, is not about choice at all. It is about direction. It is about moving towards something, or carrying something, or holding something, without wavering, without turning aside, without giving up. And in that sense, Pioneer 10 is the most devoted thing that humanity has ever made. It has not wavered, it has not turned aside, it has not given up. It is still moving, still carrying, still holding, and it will continue to do so for longer than any monument, any archive, any memory that we might build on Earth. Consider for a moment what it means to travel for 2 million years. 2 million years ago, our ancestors were not yet human. They were hominids, walking upright on the African savannah, chipping stones into crude tools, looking up at the same stars that Pioneer 10 is now travelling among. But they could not have imagined, in their wildest dreams, what those stars were. They could not have imagined that the points of light in the night sky were suns, unimaginably far away, each one perhaps surrounded by worlds of its own. They could not have imagined that one day their distant descendants would build a machine that could leave the Earth, leave the Sun, and travel toward one of those distant suns on a journey that would take longer than their entire species had existed. And yet, here we are, and here Pioneer 10 is, and the journey continues. 2 million years from now, when Pioneer 10 finally approaches the vicinity of Aldebaran, and it will only approach, it will not arrive, for it is not aimed precisely at the star, but only in its general direction. What will remain of us? What will remain of the civilization that built it, the engineers who designed it, the technicians who assembled it, the controllers who tracked it, the scientists who interpreted its data? The honest answer is that we do not know. We cannot know. 2 million years is too long for prediction, too long for planning, too long for any human institution to endure. Cities rise and fall in centuries. Empires last for millennia at most. Languages evolve beyond recognition in a few thousand years. Writing itself is only about 5,000 years old. In 2 million years, everything we know, everything we have built, everything we remember, may have been forgotten, replaced, overwritten by new civilizations and new stories that we cannot imagine. Or perhaps there will be no one left to remember at all. Perhaps the Earth will be empty, or transformed, or gone. We do not know, and we cannot know, and Pioneer 10 will not know either. It will simply continue, carrying its message, moving through the dark, indifferent to whether anyone is waiting, indifferent to whether anyone cares. There is a kind of comfort in this if you let yourself feel it. The future is not our responsibility. We did what we could. We built something beautiful, something hopeful, something that carries the best of what we were. And we let it go. We released it into the universe, knowing that we would never see it again, knowing that it would outlive us, knowing that its fate was no longer in our hands. This is what it means to plant a tree whose shade you will never sit in. This is what it means to write a letter to someone who may never read it. This is what it means to send a message into the cosmos, not because you expect an answer, but because the sending itself is the point. Pioneer 10 is our message. It is our gesture. It is our way of saying that we were here, that we wondered, that we reached out. And whether or not anyone ever receives that message, the act of sending it matters. The act of sending it is enough. It is worth pausing on what Pioneer 10 was designed to do and what it actually did, because the gap between the two is part of what makes its story so strange and so beautiful. It was designed to explore Jupiter. That was the mission. That was the reason for its existence. It was supposed to fly past the giant planet, study its atmosphere and magnetic field, photograph its moons, and send back data that would help scientists understand how the outer solar system worked. And it did all of this. It did all of this beautifully in December of 1973, when it became the first spacecraft ever to fly through the asteroid belt without being destroyed, the first to encounter Jupiter up close, the first to send back images of the Great Red Spot and the swirling bands of cloud that make Jupiter look like a living thing. For a few days, Pioneer 10 was the most important machine in the solar system. It was front-page news. It was a triumph of engineering and imagination. It had done exactly what it was designed to do. But then the mission continued. The spacecraft did not stop at Jupiter. It could not stop at Jupiter. There was no way to slow it down, no way to change its course, no way to bring it back. Jupiter's gravity had given it a boost, a slingshot effect that accelerated it to a speed that no spacecraft had ever achieved before. And with that speed came a new trajectory, a new destiny, a journey that no one had planned for but everyone had hoped for. Pioneer 10 was leaving the solar system. It was becoming the first human artifact to travel beyond the realm of the planets, beyond the orbit of Neptune, beyond the edge of the sun's gravitational influence, and out into the vast empty spaces between the stars. The people who built Pioneer 10 knew this would happen. They planned for it, they hoped for it, and they prepared a gift for whatever might be out there, a message in a bottle thrown into the cosmic ocean, a greeting from the species that had made the journey possible. The gift was a plaque, a small piece of gold, anodized aluminum, about 9 inches by 6 inches, mounted on the side of the spacecraft where it would be protected from the erosion of micrometeorites and cosmic rays. On the plaque was etched a series of symbols designed to communicate in the most universal language we could imagine who we were and where we came from. The design of the plaque was the work of 3 people: Carl Sagan, the astronomer and science communicator who would later become famous for his television series Cosmos; Frank Drake, the radio astronomer who had pioneered the search for extraterrestrial intelligence; and Linda Salzman Sagan, Carl's wife at the time, an artist who actually drew the images that would be etched into the metal. They had only 3 weeks to design the plaque, from the moment NASA approved the idea to the moment the spacecraft was launched. 3 weeks to decide what to say to the universe. 3 weeks to represent the entire human species, all of our history, all of our cultures, all of our hopes, in a single image that might not be seen for millions of years. It was an impossible task, and they knew it was impossible, and they did it anyway. Spare a thought too for what they chose to include and what they chose to leave out, because every choice was a kind of prayer. In the centre of the plaque, there are 2 figures, a man and a woman standing upright, naked, rendered in the simple, clean lines of a scientific diagram. The man's right hand is raised in greeting, a gesture that was chosen because it shows the opposable thumb, the feature of human anatomy that allows us to make tools, to write, to build spacecraft. The woman stands beside him, her posture relaxed, her hand at her side. They are meant to represent all of humanity, every culture, every nation, every variation of the human form, distilled into 2 idealized figures that might be recognizable to an intelligence that had never seen a human being before. Behind the figures, there is an outline of the spacecraft itself, drawn to scale, so that whoever finds the plaque can understand how large we are compared to the machine we built. To the left, there is a diagram of the solar system, showing the Sun and the 9 planets. 9, because Pluto was still considered a planet in 1972, with a small arrow tracing Pioneer 10's trajectory from Earth, past Jupiter, and out into space. At the top of the plaque, there is a diagram of a hydrogen atom, the most common element in the universe, undergoing a change in its spin state. This change releases a photon with a specific wavelength, about 21 centimeters, which the designers hoped would serve as a kind of cosmic ruler, a unit of measurement that any technologically advanced civilization would recognize and understand. And radiating out from a central point, there are 14 lines, each one pointing in a different direction, each one labelled with a series of binary numbers. These lines represent pulsars, rapidly spinning neutron stars that emit beams of radio waves as they rotate. Pulsars are natural lighthouses, and each one has a characteristic period, a specific rhythm of flashing that distinguishes it from all the others. The idea was that whoever found the plaque could use the pulsar map to triangulate the position of the Sun in the galaxy, to figure out exactly where this strange artifact had come from. It was a clever idea, a beautiful idea, and it may or may not work. Pulsars slow down over time. The map that was accurate in 1972 will be less accurate in 1,000 years, and perhaps unreadable in 1,000,000. But it was the best idea anyone had, and it was drawn with care, with precision, with hope. Picture, if you can, the moment when the plaque was attached to the spacecraft. It was a quiet moment, a routine moment, just another step in the long checklist of preparing a spacecraft for launch. A technician with steady hands bolting a small piece of metal to the struts of the antenna support, making sure it was secure, making sure it would survive the violence of launch and the long cold years that followed. The technician probably did not think much about what they were doing. They had a job to do, a spacecraft to prepare, a deadline to meet. But in that moment, without ceremony, without fanfare, they were attaching humanity's first deliberate message to the stars. They were making us an interstellar species, not because we had travelled to the stars ourselves, but because we had sent a piece of ourselves on the journey. A portrait, a greeting, a hope. The plaque is still there, attached to Pioneer 10, sailing through the dark. It has been there for over half a century, exposed to the faint radiation of interstellar space, cooled to the temperature of the cosmic background, waiting for the encounter that may never come. If it could feel, and of course it cannot, it might feel patient, it might feel ready, it might feel like it has been waiting all its life for the moment when someone, something, finally notices the small golden rectangle on the side of the silent machine and wonders what it means. There is one more thing worth understanding about the plaque, and it is perhaps the most poignant thing of all. The plaque was not designed for us. It was not designed to be read by humans, to be understood by humans, to comfort humans. It was designed for someone else entirely, someone who might not exist, someone who might be so different from us that we cannot imagine what they would look like or how they would think. And yet, in designing something for that imaginary audience, we revealed more about ourselves than we ever intended. We showed what we look like, yes, but we also showed what we hope for. We showed that we believe communication is possible. We showed that we believe understanding is possible. We showed that we believe, despite all the wars and cruelties and failures of our history, that there is something in the universe worth reaching out to, worth trusting, worth greeting with an open hand. This is the paradox of the Pioneer plaque. It is a message to aliens, but it is also a message to ourselves. It tells us who we want to be. It tells us what we hope is true about the universe, that it is not indifferent, that it is not hostile, that somewhere out there someone might be listening, might be watching, might be waiting to hear from us. And even if none of that is true, even if the universe is empty and cold and silent forever, the plaque still matters, because it shows what we were capable of imagining. It shows the reach of our hope. Let us sit for a long moment with the journey itself, the vast distances that Pioneer 10 has already crossed, and the vaster distances that still lie ahead. When the spacecraft launched, the distance to the nearest star, Proxima Centauri, was about 4 light-years, or roughly 24 trillion miles. Pioneer 10 is not heading toward Proxima Centauri. It is heading in a different direction entirely, toward the constellation Taurus and the red giant star Aldebaran. But the scale is similar. Aldebaran is about 65 light-years away, which means that light travelling at the fastest speed the universe allows takes 65 years to make the journey. Pioneer 10, travelling at about 27,000 miles per hour, will take considerably longer. The estimates vary, but the consensus is that it will take roughly 2 million years for Pioneer 10 to travel from where it is now to the general vicinity of Aldebaran. 2 million years, a span of time so vast that it reduces all of human history to a single heartbeat. And what will Pioneer 10 encounter along the way? What obstacles? What wonders? What dangers? The honest answer is that we do not know because we have never been there, and we have no way of knowing what lies in the particular corridor of space that Pioneer 10 is travelling through. But we can make some educated guesses based on what we know about the structure of the galaxy and the distribution of matter within it. Return with me, one more time, to the emptiness of interstellar space, because it is important to understand just how empty it really is. The density of matter between the stars is about 1 atom per cubic centimetre. That sounds like a lot, perhaps. 1 atom is something after all, but consider what it means in practice. A cubic centimetre is about the size of a sugar cube. In the room where you're lying right now, there are roughly 30 billion trillion atoms in every cubic centimetre of air. The space between the stars is 30 billion trillion times emptier than the air you're breathing. It is a vacuum so profound that nothing we can build on Earth comes close to replicating it. It is emptiness on a scale that the human mind was not designed to comprehend. And yet, even in this emptiness, there are things. There are molecules of hydrogen, drifting alone or clumped into sparse clouds. There are tiny grains of dust composed of carbon and silicon and ice, each one smaller than a grain of sand, each one a traveller like Pioneer 10, coasting through the void on journeys that began millions of years ago. There are wisps of magnetic field twisted and stretched by the rotation of the galaxy, guiding charged particles along invisible paths. There are cosmic rays, protons and atomic nuclei that have been accelerated to tremendous speeds by the shock waves of distant supernova, crisscrossing the galaxy in all directions, occasionally striking a spacecraft or a planet or a grain of dust, and leaving a tiny scar of ionization in their wake. Pioneer 10 is bathed in all of this, constantly, perpetually, for the entire duration of its journey. The cosmic rays strike its hull, knocking loose atoms of metal, slowly eroding the surface of the spacecraft over millions of years. The magnetic fields tug gently at its metal components, imparting infinitesimal changes to its trajectory that will accumulate over time into deviations we cannot predict. The grains of dust, if they strike at all, will do so with tremendous relative velocity, because Pioneer 10 is moving so fast that even a particle smaller than a grain of pollen would hit with the force of a bullet. Most of the spacecraft's journey will be uneventful. The spaces between the stars are so empty that collisions are rare. But over 2 million years, even rare events accumulate. Even tiny probabilities become certainties. Pioneer 10 will be scarred, pitted, eroded, transformed by its journey through the void. It is worth trying just once to feel what that transformation might mean. The spacecraft that left Earth in 1972 was shiny, new, covered in reflective thermal blankets that gleamed in the sunlight of the inner solar system. The spacecraft that exists today is faded, darkened, its blankets dulled by decades of exposure to ultraviolet light and cosmic radiation. And the spacecraft that will arrive near Aldebaran 2 million years from now will be different still. A relic, a fossil, a piece of ancient technology so weathered and worn that it might be difficult to recognise as anything artificial at all. The plaque will still be there, protected by its position on the spacecraft's structure, but even the plaque will have changed. The gold anodizing may have flaked away. The etched lines may have been softened by the constant rain of micrometeorites. The message will still be readable, perhaps, but it will be a message from a very long time ago, a message from a civilization that no longer exists, written in symbols that may or may not still make sense, and we cannot leave this story without acknowledging the silence, the deep and final silence that descended over Pioneer 10 on January 23, 2003, when the last faint signal was received and the spacecraft slipped beyond the reach of our most sensitive antennas. That signal was weak, so weak that it was barely distinguishable from the background noise of the universe. It had travelled for more than 7 billion miles, taking over 11 hours to reach Earth, arriving as a whisper that only the most sophisticated receivers could detect, and then it was gone. The transmitter, powered by the decaying plutonium in the spacecraft's radioisotope thermoelectric generators, had finally fallen below the threshold of detectability. Pioneer 10 had not stopped transmitting. It had simply become too quiet to hear. The people who had spent their careers tracking Pioneer 10 gathered one last time to listen for that final signal. They knew it would be the end of an era, the end of a relationship that had lasted more than 30 years. They knew they would never hear from the spacecraft again. And so, they listened, with their ears and their instruments and their hearts, as the faint carrier wave flickered in and out of detectability, growing weaker with each passing hour, until finally there was nothing left but the hiss of cosmic static, the background murmur of the universe itself. The spacecraft was still out there. It would always be out there. But it had passed beyond the realm of the knowable, into a darkness where we could only imagine what was happening, where we could only calculate where it must be, where we could only hope that it was still intact, still carrying its message, still faithful to its mission. This is the strange gift of Pioneer 10's silence. It has freed us from the burden of knowledge. We do not have to watch it fail. We do not have to witness its decay. We do not have to receive a final transmission confirming that its systems have shut down, its trajectory has changed, its journey has come to an end. Instead, we are left with uncertainty, with hope, with the comforting ambiguity of not knowing. And in that not knowing, there is room for imagination. There is room for faith. There is room to believe that somewhere out there in the vast and patient dark, a small machine is still doing exactly what it was built to do, travelling, carrying, enduring, and that it will continue to do so for as long as anything in the universe continues to exist. The night sky is full of stars, and each one is a sun, and some of those suns have planets, and on some of those planets there may be life, and some of that life may be intelligent, and some of that intelligence may be curious, and some of that curiosity may lead them to build telescopes and spacecraft and messages of their own. We do not know if any of this is true. We have no evidence that life exists anywhere beyond Earth, no confirmation that intelligence is common in the universe, no signal from the stars that tells us we are not alone. But we hope. We have always hoped. And Pioneer 10 is the physical manifestation of that hope, a small machine carrying a golden message through the dark on a journey that will take longer than human civilization has existed, toward a destination that may or may not have anyone waiting to receive it. And that perhaps is the most beautiful thing about Pioneer 10. It does not require an audience. It does not require a response. It does not require anyone to find it, decode its message, understand its meaning, or care about its origin. It is its own reward. The act of sending it was enough. The act of hoping was enough. The act of reaching out, even into emptiness, even into silence, even into the void where no answer will ever come. That act is what makes us human. That act is what makes us worthy of the stars. That act is what Pioneer 10 carries with it, more surely than any diagram or symbol etched into gold. And so it continues tonight, while you rest, growing more distant with every breath you take. It is worth pausing on the nature of the journey itself, on what it means to travel so far that distance becomes something other than distance, something more like time made visible, stretched across the dark in a line so long that no human mind can truly hold it. Pioneer 10 is not flying toward Aldebaran in the way that an airplane flies toward a city, or even in the way that a comet falls toward the sun. It is drifting, it is coasting, it has not fired an engine in decades, has not adjusted its course, has not made any decision at all. The momentum it carries now is the same momentum it gathered from Jupiter in December of 1973, when it swung past the giant planet and borrowed a little of its orbital energy, using gravity itself as a slingshot. That encounter happened when many of the people now reading these words had not yet been born. It happened in a world without personal computers, without the internet, without mobile phones, in a world where the Cold War still divided the Earth, and the moon landings were a recent memory, and the future seemed like something that might include flying cars and colonies on Mars, and the energy Pioneer 10 gained from Jupiter in that distant encounter, energy that it stole, in a sense, from the planet's own slow orbit around the Sun, that energy is still carrying it forward today. The spacecraft has not slowed down in any meaningful way. There is almost nothing out there to slow it down. No air, no friction, no resistance. Just the faint, patient tug of the Sun's gravity, still reaching out across all those billions of miles, still pulling gently backward, still trying to reclaim what left. But the Sun is too far away now, and Pioneer 10 is moving too fast. The tug grows weaker with every passing year, and the spacecraft will never return. It has escaped. It is free. And yet freedom in this context is a strange and lonely thing. To escape the solar system is to leave behind everything that made the journey possible. The engineers who designed the spacecraft, the technicians who assembled it, the controllers who monitored it, the scientists who studied its data, all of them are bound to the Earth, bound to the Sun, bound to the small warm pocket of space where life is possible. Pioneer 10 has left them all behind. It has left behind the planets, the asteroids, the comets, the dust, the magnetic fields, the solar wind, the faint warmth of a star that once gave it purpose. It is entering a realm where there is nothing but hydrogen atoms drifting through the void, perhaps 1 atom per cubic centimetre, a vacuum so complete that it makes the best laboratory vacuums on Earth seem thick and crowded by comparison. This is the interstellar medium, the space between the stars, the great emptiness that fills most of the galaxy. And Pioneer 10 is passing through it now, a tiny mote of metal and silicon and gold, no larger than a grand piano carrying a message that no one may ever read. Consider for a moment what it means to travel for 2 million years. Human beings have existed as a species for perhaps 300,000 years. Recorded history, writing, cities, agriculture, everything we think of as civilization, spans only about 5,000 years. The pyramids of Egypt were built less than 5,000 years ago. The Roman Empire rose and fell less than 2,000 years ago. The Renaissance, the Enlightenment, the Industrial Revolution, the Digital Age, all of it. The entire arc of human progress from the first cave paintings to the spacecraft that now drift through the outer solar system. All of it fits into a span of time that is less than 1% of the journey Pioneer 10 has undertaken. When Pioneer 10 reaches the vicinity of Aldebaran, assuming nothing interrupts its path, human civilization will have had time to rise and fall hundreds of times over. The Earth itself may be unrecognizable. The Sun will still be shining, still burning hydrogen in its core, still warming the inner planets with its light. But what will be happening on those planets? Who will be living there? Whether anyone will remember that a small machine was once sent out into the darkness with a golden postcard attached? These are questions that no one can answer. The future is as unknown to us as the depths of interstellar space, and Pioneer 10 is travelling into both. Spare a thought too for the star itself, for Aldebaran, the destination that Pioneer 10 will never truly reach. Aldebaran is an orange giant, a star that has exhausted the hydrogen in its core and swelled to many times its original size. If you placed Aldebaran where the Sun is now, its surface would extend past the orbit of Mercury, past Venus, almost to the orbit of Earth itself. It is a star in its old age, a star that has already lived most of its life, a star that will eventually shed its outer layers and collapse into a white dwarf, leaving behind only a small, dense remnant of what it once was. And this is the strange thing. By the time Pioneer 10 arrives in the vicinity of Aldebaran 2 million years from now, Aldebaran itself may no longer exist in its current form. Stars on the scale of Aldebaran do not last forever. They burn through their fuel, they expand, they contract, they die. The Aldebaran that we see tonight in the constellation Taurus, the bright orange eye of the bull, may be a white dwarf by the time Pioneer 10 passes by, or it may have dissipated entirely into a planetary nebula, a glowing shell of gas expanding into the darkness. Pioneer 10 is travelling toward a destination that is itself travelling through time, changing, aging, dying, in ways that we can predict but never witness. And this is where the journey becomes something more than physics, something more than engineering, something more than the simple fact of motion through space. This is where the journey becomes a meditation on impermanence, on the strange and beautiful fact that nothing in the universe stays the same, that everything is in motion, that stars are born and die, that galaxies collide and merge, that the universe itself is expanding, carrying everything farther and farther apart with every passing moment. Pioneer 10 is not travelling through a static backdrop. It is travelling through a living cosmos, a cosmos that is changing around it even as it moves, a cosmos that will look utterly different by the time the spacecraft reaches its nominal destination. The stars that we see tonight are not the stars that Pioneer 10 will pass. The constellations that we know, Orion, Ursa Major, Cassiopeia, are temporary patterns, human inventions imposed on a sky that is itself in flux. In 100,000 years, the stars will have drifted enough that the constellations will be unrecognizable. In 1,000,000 years, the night sky will belong to a different age, a different Earth, a different humanity, if humanity still exists at all. And yet Pioneer 10 will continue. That is the remarkable thing. The spacecraft does not care about constellations, does not know about Aldebaran, does not have any sense of destination or purpose or time. It simply moves. It simply endures. It carries its golden plaque through the changing cosmos, through the births and deaths of stars, through the slow rearrangement of the galaxy, through epochs that no human being will ever witness. And in this endurance, there is something that feels almost like faith. Not the faith of the spacecraft itself, which has no capacity for faith, but the faith of the people who sent it, the faith that the universe is worth exploring even if we will never see the results, the faith that the act of reaching out matters even if no one is there to receive. Return with me, one more time, to that final signal, to the last moment when Pioneer 10 spoke to us across the gulf of space. It was January 2003. The spacecraft was more than 7 billion miles from Earth, so far away that its radio signal, travelling at the speed of light, took more than 11 hours to reach us. Imagine sending a message and waiting nearly a full day for a response. Imagine a conversation stretched across hours, across light hours, across a distance so vast that the spacecraft you were talking to had already moved millions of miles by the time your words arrived. This was the reality of communicating with Pioneer 10 in its final years. The Deep Space Network, with its massive dish antennas spread across California and Spain and Australia, would aim at a point in the sky where Pioneer 10 would be by the time the signal arrived, accounting for the spacecraft's motion, accounting for the Earth's rotation, accounting for the slight wobble of our planet on its axis. And then they would wait, listening for a response that might never come, hoping that the spacecraft's transmitter still had enough power to be heard, hoping that its antenna was still pointed in the right direction, hoping that the delicate electronics had survived another year in the cold and the radiation and the loneliness of deep space. The signal they received was so faint that it required enormous dishes and sophisticated receivers just to detect it at all. The transmitter on Pioneer 10 was no more powerful than a refrigerator light bulb, 8 watts of radio energy spreading out in all directions, diluted by distance until it was barely distinguishable from the cosmic microwave background, the faint afterglow of the Big Bang itself. To pick out that signal from the noise was an act of almost impossible precision, like hearing a single whisper across a crowded stadium, across a city, across a continent, across an ocean, across a planet, across a gulf of emptiness that dwarfed everything that had come before. And yet they heard it. For more than 30 years they heard it. That faint whisper from the edge of the solar system, that carrier wave wobbling with the slight Doppler shift of the spacecraft's motion, that confirmation that something human-made was still out there, still functioning, still faithful. And when the whisper finally faded, when the signal dropped below the threshold of detectability and did not return, there was grief, real grief, among the people who had spent their lives listening. They had known the spacecraft as a colleague, as a companion, as a presence in their daily work. They had tracked its position, calculated its trajectory, monitored its health, celebrated its milestones, worried about its diminishing power. They had anthropomorphized it, as humans always do with the machines they love, giving it personality and purpose and will, and when it fell silent they felt the loss as surely as if a friend had moved away to a place where letters could no longer reach. The spacecraft was still out there. They knew it was still out there. But the relationship had ended. The conversation was over. From now on, Pioneer 10 would be a memory, a calculation, a dot on a star map, a trajectory extrapolated into the inconceivable future. It would never speak again. There is one more thing worth understanding about Pioneer 10's silence, and it is this. The silence is not a failure. The spacecraft was not designed to last forever. It was designed to survive a journey to Jupiter, to study the planet and its moons, to return data about the radiation belts and the magnetic field, and the composition of the Jovian atmosphere. Everything after that was a gift, a bonus, a testament to the skill of the engineers who built it, and the persistence of the controllers who kept it alive. Pioneer 10 exceeded every expectation. It lived longer than anyone had a right to hope. It travelled farther than any human artifact had ever travelled. And when it finally fell silent, it did so not because it had failed, but because it had succeeded so completely that there was nothing left for it to give. The silence is not an ending, it is a graduation. It is the moment when the spacecraft moved beyond our ability to follow, into a realm where it would continue without us, carrying our message into a future that belongs to it alone. Picture, if you can, the spacecraft as it is tonight. It is dark out there, darker than anything you have ever experienced, darker than the deepest cave, darker than the ocean floor, darker than the space between your closed eyelids when you drift towards sleep. The sun, from Pioneer 10's vantage point, is just another star, brighter than most but not by much. A point of light among countless other points of light, no longer the dominant presence it was when the spacecraft was young. There is no warmth, there is no wind, there is no sound except the faint tick of cosmic rays striking the hull, the occasional particle of interstellar dust impacting at tremendous speed, the subtle creak of metal contracting in the cold. If metal can creak in a vacuum, if sound can exist where there is nothing to carry it. The spacecraft is alone in a way that nothing on Earth has ever been alone, and yet it is not empty. It carries its instruments, silent now but still intact. It carries its antenna, still pointed toward a home it can no longer see. It carries its golden plaque, still affixed to its side, still bearing the images and symbols and diagrams that Carl Sagan and Frank Drake and Linda Salzman designed half a century ago. When the world was young, and the future seemed bright, and the idea of sending a message to the stars seemed like the most hopeful thing a species could do. Let us sit for a long moment with that plaque, with what it represents, with what it says about us. The plaque is small, just 9 inches by 6 inches, about the size of a license plate. It is made of gold anodized aluminum, a material chosen because it is resistant to corrosion, because it will endure in the vacuum of space, because it will not degrade over the millions of years of the journey ahead. Etched into its surface are images that were meant to be universal, meant to communicate across any barrier of language or biology or time. There is a diagram of the hydrogen atom, the most common element in the universe, undergoing its most fundamental transition, the flip of an electron spin that produces a radio wave with a wavelength of 21 centimeters. This wavelength is the key to the entire plaque, the unit of measurement that any scientifically advanced civilization should recognize, the Rosetta Stone that unlocks all the other diagrams. There is a map of 14 pulsars, rapidly spinning neutron stars that emit radio waves with precise and regular timing, each one identified by its period, its unique fingerprint, its location in the galaxy. By measuring the periods of these pulsars, an alien civilization could triangulate the position of our sun, could determine when the spacecraft was launched, could pinpoint our location in space and time with remarkable accuracy. There is a diagram of the solar system, a simple schematic showing the sun and its 9 planets. 9 because Pluto was still a planet in 1972, with Pioneer 10's trajectory marked, showing that it came from the 3rd planet, the blue one, the one with water and air and life. And there are the figures, the 2 human silhouettes, a man and a woman, standing before a schematic of the spacecraft itself, their proportions rendered in terms of the hydrogen wavelength, their hands raised in what was meant to be a gesture of greeting, of openness, of peace. These figures are perhaps the most controversial part of the plaque, the part that has generated the most discussion and the most criticism over the years. Some have complained that the figures are too European, too specific, not representative of all humanity. Some have noted that the man's hand is raised while the woman stands passively beside him, a reflection of the gender dynamics of the era in which the plaque was designed. Some have wondered whether any alien civilization could possibly decode these images, whether the very concepts of male and female bodies would mean anything to a species that might reproduce in entirely different ways. These are valid concerns, thoughtful objections, important conversations to have. But they miss something essential about the plaque, something that transcends the specifics of its design. The plaque is not a perfect message. It was never meant to be. It is a human message, with all the limitations and blind spots and cultural assumptions that implies. It is a message from a particular species, at a particular moment in history, reaching out into the unknown with the best tools available. And the fact that it is imperfect, the fact that it reflects our biases and our hopes and our fears, the fact that it is as much a portrait of us as it is a message to them, this is what makes it beautiful. This is what makes it true. And we cannot leave this story without acknowledging the people who made it possible, the engineers and scientists and dreamers who built Pioneer 10 and sent it on its way. They worked in an era before computer-aided design, before satellite navigation, before most of the technologies that we now take for granted. They calculated trajectories by hand, checked their work with slide rules, tested their assumptions with physical models and analog computers. They built a spacecraft that could survive the radiation belts of Jupiter, where the charged particles were so intense that they could fry electronics in minutes, and they did it without ever having tested anything in such an environment, because no one had ever been there before. They were pioneers in the truest sense of the word, exploring a frontier that existed only in their calculations and their imaginations, trusting that the laws of physics would hold true across distances that no human being could ever cross. And they succeeded. Against all odds, against all skepticism, against all the voices that said it couldn't be done, they built a machine that is still travelling today, still carrying their message, still faithful to their vision. It is worth trying, just once, to feel what they must have felt on that March morning in 1972, when Pioneer 10 lifted off from Cape Canaveral on an Atlas Centaur rocket, rising through the Florida sky on a column of fire and smoke, carrying with it the hopes of everyone who had worked on it, everyone who had dreamed of the stars, everyone who believed that humanity could reach beyond its cradle and touch something greater than itself. They watched it climb, watched it disappear into the blue, watched the telemetry come in confirming that the spacecraft was healthy, that the trajectory was correct, that everything was working as designed. And then they went back to their offices, back to their labs, back to their screens and their printouts and their endless calculations, and they waited. They waited for the spacecraft to cross the asteroid belt, which some had said would be impossible, which some had predicted would end the mission in a shower of debris. They waited for the spacecraft to reach Jupiter, to survive the radiation, to return its images and its data. They waited for year after year, decade after decade, as the spacecraft travelled farther and farther, as the signal grew fainter and fainter, as the mission became something no one had ever imagined, a voyage into forever. There is a smaller, quieter story woven through all of this, a story about the people who kept listening even after the formal mission had ended, even after the funding had dried up, even after most of the original team had retired or passed away. These were the faithful few, the dedicated listeners, the ones who could not bear to let go of a spacecraft that had given them so much. They volunteered their time, scrounged for resources, convinced observatories to point their antennas at a faint dot in the sky that most people had forgotten existed. They tracked Pioneer 10 not because they expected to learn anything new, not because there was any scientific value in the data, but because the spacecraft was still out there, still travelling, still carrying its message, and someone needed to witness that journey, someone needed to remember. And when the final signal came, when the last faint whisper was detected and recorded and confirmed, they were the ones who heard it. They were the ones who said goodbye, and now the spacecraft travels on, beyond the reach of any antenna, beyond the knowledge of any observer, beyond the concern of any institution. It is alone with the stars, alone with its message, alone with the 2 million years of silence that lie ahead. And in that silence, there is something that feels almost like peace. The peace of a journey completed, a mission fulfilled, a message delivered to the only audience that matters, the universe itself. Pioneer 10 does not need anyone to find it. It does not need anyone to decode its plaque or understand its origins or remember its name. It is enough that it exists, that it travels, that it carries a piece of us into the infinite. It is enough that somewhere out there, in the darkness between the stars, a small machine is still doing exactly what it was built to do, and it is still doing it tonight. Consider for a moment the shape of the journey that lies ahead. Pioneer 10 is travelling in a direction that astronomers have mapped with extraordinary precision, a course that will carry it generally toward a star called Aldebaran, the bright orange eye of the constellation Taurus, a star that ancient sailors used to navigate and that modern astronomers know to be a dying giant, swollen and cooling, nearing the end of its own long life. But the word toward is almost misleading here, because the distances involved are so vast that language begins to fail, that our ordinary sense of direction and destination dissolves into something closer to abstraction. Aldebaran is roughly 65 light-years away, which means the light you see when you look at it tonight left that star around the time your grandparents were young, around the time the world was recovering from a war, around the time the very idea of spaceflight was still the province of dreamers and eccentrics. And Pioneer 10, travelling at its current speed of roughly 27,000 miles per hour, will not reach the vicinity of Aldebaran for approximately 2 million years. 2 million years. Let that number settle into you like a stone dropping into still water. 2 million years ago, there were no humans as we know them, no cities, no languages, no written words, no music, no art. 2 million years ago, our ancestors were small creatures on an African savanna, just beginning to walk upright, just beginning to make tools from stone, just beginning the long, slow climb toward everything we would become. And in 2 million years, when Pioneer 10 finally drifts into the neighbourhood of that distant orange star, what will we be then? What will we have become? Will there be anyone left to remember that we ever existed, that we ever sent a small machine out into the darkness with a message scratched onto a golden plaque? The honest answer is that we cannot know. The honest answer is that the future is as opaque to us as the past was to those small creatures on the savannah, who could not have imagined the cathedrals and the symphonies and the spacecraft that their distant descendants would build. And so Pioneer 10 travels on, carrying its message into a future that is utterly unknowable, utterly beyond our reach, utterly indifferent to our hopes and fears and dreams. But there is something beautiful in that indifference, something liberating, something that feels almost like a gift. Pioneer 10 does not need the future to be kind. It does not need anyone to be waiting. It is simply going, simply travelling, simply doing what it was made to do, and that is enough. Return with me one more time to the question of what surrounds Pioneer 10 tonight, in this particular moment of its endless journey. The spacecraft has travelled far beyond the orbit of Pluto, far beyond the scattered disk of icy objects that marks the outermost reaches of our solar system, far into a region where the sun is just another star among thousands, where the familiar constellations of Earth's night sky have begun to shift and distort, where the very concept of up and down has lost all meaning. Out here, in the deep interstellar medium, there is almost nothing. A few atoms of hydrogen per cubic centimetre, drifting like dust motes in an empty cathedral, remnants of ancient supernovae and stellar winds and the slow churning of the galaxy itself. The temperature hovers just a few degrees above absolute zero, cold enough to freeze any liquid, cold enough to slow any chemical reaction to a crawl, cold enough to preserve whatever is placed within it for timescales that dwarf the entire history of life on Earth. And Pioneer 10 drifts through this emptiness, this vast and silent nothing, like a seed scattered on a cosmic wind, like a message in a bottle thrown into an ocean without shores. The spacecraft's power source has long since faded to silence. The plutonium dioxide that once generated enough electricity to run the instruments and transmit the signal has decayed past the point of usefulness, its warmth slowly bleeding into the surrounding void, its energy dissipating into the infinite cold. The instruments that once measured magnetic fields and cosmic rays and the solar wind are dark now, their circuits still and silent, their work complete. The antenna that once pointed faithfully toward Earth, that once whispered its data across billions of miles, is just a metal dish now, a sculpture drifting through the darkness, oriented toward a planet it can no longer reach. And yet the spacecraft is intact. The hull is still whole, the components still in their places, the golden plaque still mounted on the antenna support struts, still etched with its images and its diagrams, still carrying its message to anyone who might someday find it. It is worth pausing on what preservation means in a place like this. On Earth, everything decays. Wood rots, metal rusts, stone erodes, even the most durable materials are slowly broken down by water and oxygen and sunlight, and the ceaseless activity of life itself. We build monuments and write books and carve our names into stone, and time reduces all of it to dust, to fragments, to the faint whisper of a memory. But in the interstellar medium, the rules are different. There is no oxygen to corrode the metal, no water to seep into the joints, no bacteria to consume the organic compounds, no wind or rain or ice to wear away the surfaces. There is only the cold and the dark and the silence, and in that silence things can last for a very, very long time. The golden plaque on Pioneer 10 is made of gold anodized aluminum, chosen specifically for its resistance to corrosion, its ability to withstand the radiation and the cold of deep space. The etchings on its surface, the diagrams and the figures and the symbols were designed to be legible for billions of years, to survive the slow erosion of cosmic rays and the gentle sandblasting of interstellar dust. And so, the plaque endures, drifting through the darkness, carrying its message through timescales that make human civilization look like a single heartbeat, a single breath, a single flash of light in an endless night. Spare a thought too for what the plaque actually says, for the message that those scientists and artists and dreamers encoded on that small rectangle of gold. The design was created in just 3 weeks by Carl Sagan and Frank Drake, with artwork by Linda Salzman Sagan, Carl's wife at the time, who drew the 2 human figures that stand at the centre of the image. The plaque shows a man and a woman, nude and unadorned, standing in front of a silhouette of the Pioneer spacecraft, rendered to scale so that any finder could gauge our size. The man's hand is raised in what the designers hoped would be understood as a universal gesture of greeting, of peace, of friendly intent. The woman stands beside him, her posture relaxed, her face calm, her presence suggesting that we are a species of 2 sexes, of partnership, of community. Behind them, the spacecraft provides a reference for scale and technology, suggesting that we are a species capable of building machines, of reaching beyond our world, of imagining the stars. And surrounding these figures, the plaque is covered with diagrams intended to communicate the one thing any finder would need to know: where we came from. The most striking of these diagrams shows the Sun's position relative to 14 pulsars, rapidly spinning neutron stars that emit precise and regular bursts of radio waves, like cosmic lighthouses flashing in the darkness. Each pulsar is represented by a line radiating from a central point, with the length and orientation of each line encoding the pulsar's frequency and direction. This pattern was chosen because pulsars are among the most stable timekeepers in the universe, their frequencies so precise that they can serve as reference points for millions of years. Any civilization advanced enough to find Pioneer 10, advanced enough to understand what it was and where it came from, would likely be familiar with pulsars, would likely be able to use this diagram to triangulate the Sun's position, to trace the message back to its source, to find us, or at least to find the place where we once were. There is one more thing worth understanding about the plaque, a detail that reveals something profound about the people who made it and the hopes they carried. At the bottom of the plaque, there is a diagram showing the relative positions of the planets in our solar system, from Mercury close to the Sun to Pluto at the outer edge, and there is a small arrow showing the trajectory of Pioneer 10, arcing out from Earth, past Jupiter, and into the darkness beyond. This arrow is both a map and a confession. It says, we are small. We live on the 3rd rock from an ordinary yellow star, in an ordinary spiral arm of an ordinary galaxy, in an ordinary corner of an ordinary universe. We have not travelled far. We have only just begun to reach beyond our home. But we are reaching, and this spacecraft is the proof. It is the first thing we ever sent out of the inner solar system, the first emissary from our small blue world to the vast and silent reaches of interstellar space. And we wanted you to know. Picture, if you can, what it would be like to find this plaque. to be the one who discovers Pioneer 10 drifting through the darkness 2 million years from now. Imagine the wonder, the confusion, the slow, dawning recognition that this small machine was not natural, was not formed by the random collisions of matter and energy, was designed and built and launched by beings with minds and hands and hopes. Imagine tracing the pulsar map, triangulating the position of a small yellow star, realizing that somewhere in the galaxy, long ago there was a world where creatures looked up at the night sky and wondered what was out there, and decided to send a message, and trusted that someone, someday, might hear it. We cannot know if that moment will ever come. We cannot know if Pioneer 10 will ever be found, if the plaque will ever be seen by eyes that are not human, if the message will ever be understood. The odds are almost certainly against it. Space is vast beyond comprehension, and Pioneer 10 is small beyond imagining, and the chances of any encounter are so remote that they barely register as probabilities at all. But the plaque was never really about being found. It was about the act of sending, the decision to reach out, the hope that we're not alone, the faith that the universe is worth talking to even if it never talks back. Carl Sagan understood this. In his writings about the plaque and about Pioneer 10, he spoke of the spacecraft as a kind of message in a bottle, thrown into a cosmic ocean, with no expectation of reply but with the simple human need to say, "We were here, we existed. We wondered and dreamed and built and hoped, and we wanted the universe to know." Let us sit for a long moment with the question of silence, with the particular kind of quiet that surrounds Pioneer 10 now that no one is listening anymore. The last confirmed signal from the spacecraft was received on January 23, 2003, a date that feels both recent and ancient, a date from a world that was similar to ours in many ways and different in others, a world where the towers had just fallen and the wars had just begun, and the smartphones had not yet arrived. On that day, the Deep Space Network's antenna at Goldstone, California, detected a faint whisper from Pioneer 10, a signal so weak that it had to be extracted from the noise through careful analysis, a signal that carried no data, only the confirmation that the spacecraft was still alive, still transmitting, still doing its job even though no one expected it to anymore. And then the signal stopped. Not dramatically, not suddenly, not in a way that suggested any particular event or failure. It simply faded below the threshold of detection, became indistinguishable from the background radiation of the universe itself, and was lost. The Deep Space Network continued to listen for several more years, pointing its great dishes at the coordinates where Pioneer 10 should have been, hoping for one more whisper, one more confirmation, one more goodbye. But none came, and eventually the listening stopped too, and Pioneer 10 passed from the realm of the known into the realm of the imagined, from a spacecraft we could contact into a spacecraft we could only remember. And we cannot leave this story without acknowledging what that silence means, what it feels like to lose contact with something you have tended for so long. The engineers and scientists who worked on Pioneer 10, who tracked it for 3 decades, who celebrated its triumphs and worried over its malfunctions and gradually came to think of it as something almost like a friend. They felt that loss keenly. They had invested years of their lives in this small machine, had followed its journey from the green hills of Florida to the red clouds of Jupiter, to the black void beyond Pluto, had listened to its voice grow fainter and fainter until it was just a whisper, and then until it was nothing at all. And when the silence came, they did not forget. They remembered. They told stories. They gathered at conferences and reunions and memorial services, and they spoke of Pioneer 10 with the kind of affection that people usually reserve for family members, for childhood homes, for places and people and things that shaped who they became. The spacecraft had given them purpose. It had given them wonder. It had given them the profound satisfaction of doing something that had never been done before, of reaching beyond the known, of touching the infinite. And even though the spacecraft was gone, even though the signal had faded into silence, the gift remained. The wonder remained. The memory remained. There is a smaller, quieter comfort in understanding that Pioneer 10's silence is not the same as Pioneer 10's absence. The spacecraft is still out there tonight, still travelling, still carrying its plaque, still doing exactly what it was designed to do. It has simply passed beyond our ability to hear it, beyond the reach of our largest antennas, beyond the sensitivity of our most sophisticated receivers. But it is not gone, it is not destroyed, it is not lost in any meaningful sense. It is simply far away, farther than anything we have ever tracked, farther than anything we can currently reach, but still there, still real, still faithful to its original mission even though no one is watching anymore. And in a sense, this is the most profound kind of faithfulness, the most remarkable kind of dedication. Pioneer 10 does not know that we have stopped listening. It does not know that the transmitter has failed, that the power has faded, that the signal no longer reaches home. It simply continues, driven by the same momentum it has carried since 1973, guided by the same laws of physics that have governed its trajectory for half a century, pointed toward the same distant star that it will not reach for 2 million years. It is doing its job. It is fulfilling its purpose. It is being exactly what it was made to be, a messenger, a traveller, a small piece of human hope cast into the infinite. Consider for a moment the nature of the journey that lies between Pioneer 10 and Aldebaran, the 2 million years of travel through a region of space that is almost entirely empty, almost entirely dark, almost entirely silent. In that vast span of time, the spacecraft will encounter almost nothing. A few atoms of hydrogen drifting in the interstellar medium. Perhaps, once in a very great while, a grain of cosmic dust smaller than a mote of pollen, travelling on its own ancient trajectory through the galaxy. Perhaps at some point the faint gravitational tug of a passing star shifting the spacecraft's course by a fraction of a degree, nudging it toward or away from its eventual destination. But mostly there will be nothing. Mostly there will be silence. Mostly there will be the long, slow drift through the darkness, year after year, century after century, millennium after millennium, until words like soon and far lose all connection to human experience, until the journey becomes something outside of time, outside of story, outside of everything we know how to measure or describe. And Pioneer 10 will endure. The cold will preserve it, the emptiness will protect it, the laws of physics will carry it forward, steady and unchanging toward a destination it cannot know and a future it cannot imagine. And somewhere in some distant era, on some distant world, someone might look up at the stars and wonder if there is anyone else out there, might build their own spacecraft and send their own message, might discover, drifting through the darkness, a small machine from a small world carrying a golden plaque, carrying a story, carrying the simple human hope that we are not alone. It is worth trying, just once, to feel the scale of what Pioneer 10 represents, to understand why this small spacecraft matters so much to those who know its story. It is not the most advanced machine we have ever built. It is not the most sophisticated or the most capable or the most scientifically valuable. Its instruments are primitive by modern standards, its computers laughably simple, its power source depleted and silent. But it was the first. It was the one that proved it could be done, that showed us that the outer solar system was within our reach, that demonstrated the possibility of sending a machine beyond the inner planets and into the vast unknown. And in being first, it carried a burden and a privilege that no other spacecraft can share. It broke the trail. It showed the way. It gave us the confidence to build Voyager, to send Cassini to Saturn, to launch new horizons toward Pluto, to dream of missions to the stars themselves. Every probe we send outward, every spacecraft we launch toward the outer planets and beyond, owes something to Pioneer 10, to the small, brave machine that proved it was possible, that showed us the way, that ventured into the unknown and came back with wonders. And now it travels on, beyond our reach, beyond our knowledge, beyond our concern. It carries no instruments that we can read, transmits no signal that we can hear, reports no data that we can analyze. It is simply there, simply moving, simply existing in a way that requires no audience and no witness. And in that simplicity, there is something that feels almost like grace, almost like peace, almost like the quiet satisfaction of a task completed and a purpose fulfilled. Pioneer 10 does not need us anymore. It does not need our attention or our admiration or our memory. It has become something larger than any individual mission, larger than any human lifespan, larger than the civilization that built it. It has become a fact of the universe, a small piece of matter moving through space, carrying a message that may or may not ever be found, travelling toward a star that may or may not still exist when it arrives. It has become what it was always meant to be, a voyager, an emissary, a small golden thread connecting us to the infinite. And tonight, while you rest, while you settle into the quiet of your own small corner of the world, Pioneer 10 continues its journey. It is out there right now, moving through the darkness at 27,000 miles per hour, growing more distant with every breath you take, more remote with every heartbeat, more alone with every passing moment. And yet it carries us with it. It carries the plaque, the message, the hope. It carries the hands that built it, the minds that designed it, the hearts that launched it into the sky on that March morning in 1972. It carries the faithful listeners who tracked it for 30 years, the devoted engineers who kept it alive long past its expected lifespan, the dreamers who believed that we could reach the stars and decided to prove it. All of them are out there with Pioneer 10, travelling through the darkness, moving toward Aldebaran, journeying into a future that none of them will ever see. And in that journey, there is something that transcends the small concerns of any single life, any single era, any single world. There is something that connects us to the vastness of the cosmos, to the billions of years that came before us, and the billions of years that will come after, to the simple and profound fact that we exist, that we wonder, that we reach. Silence is not the same as gone. Consider for a moment what silence means to a machine that was never designed to feel it. Pioneer 10 was built in an era when spacecraft were expected to be conversational, to chatter constantly with their makers, to report every reading and every measurement and every flicker of data as it happened. Its designers gave it a voice, a small transmitter that could whisper across millions of miles, and they gave it ears, receivers that could pick up the faintest commands from a world it would never see again. For 3 decades that conversation continued, a dialogue between a wandering machine and the people who loved it, a back and forth that spanned distances the human mind can barely comprehend. And then, on January 23, 2003, the conversation ended. The last signal from Pioneer 10 was so faint that it took nearly 11 hours to reach Earth, travelling at the speed of light across a gulf of more than 7 billion miles. The engineers at the Deep Space Network, those patient listeners who had kept faith with the little spacecraft for more than 30 years, strained to hear it, coaxing their massive radio telescopes to focus on a point in the sky where nothing was visible, where nothing would ever be visible to the human eye. And what they heard was barely there at all, a whisper so soft that it was almost indistinguishable from the background noise of the universe itself. But it was real. It was Pioneer 10, reaching out one last time, saying something that no one could quite understand, but saying it nonetheless. The signal carried no useful data. The spacecraft's transmitter had grown too weak to send anything coherent, and its power source had faded too far to support any meaningful communication. What arrived at Earth that day was simply a carrier wave, a tone, a presence rather than a message. It was Pioneer 10 announcing that it still existed, that it was still out there, that the journey continued even if the conversation did not. And then, after that final faint whisper, there was nothing more. We tried to reach it again, of course. In March 2006, the Deep Space Network made one last attempt to contact Pioneer 10, aiming powerful radio signals at the point in space where calculations suggested the spacecraft should be, waiting and listening for any response. The signals reached out across the void, travelling for hours at the speed of light, and found nothing that answered. Either Pioneer 10's receiver had failed, or its transmitter had grown too weak to reply, or the spacecraft had simply moved beyond the range where communication was possible. Whatever the reason, the silence was complete. And so, Pioneer 10 joined the company of things that exist without being observed, things that travel without being tracked, things that continue without any witness to mark their passage. It is still out there tonight, still moving, still carrying its instruments and its plaque and its small freight of human hope. But we can no longer speak to it, and it can no longer speak to us. The conversation that began on a launch pad in Florida more than half a century ago has ended, and what remains is simply motion, simply existence, simply the quiet continuation of a journey that no longer needs our attention to be real. It is worth pausing on what Pioneer 10 has left behind, now that it has passed beyond our reach. The spacecraft itself is remarkably small by the standards of later missions. Its body is hexagonal, about 9 feet across, covered in instruments and sensors that were considered cutting edge in 1972, but would seem almost quaint today. Its antenna, the great dish that once pointed faithfully back toward Earth, is about 9 feet in diameter, a shallow bowl of metal that spent decades catching the faintest whispers from home and sending its own whispers in reply. Its total mass, including all the instruments and all the hardware and all the hopes and dreams that went into building it, is about 570 pounds, lighter than many motorcycles, lighter than some professional athletes, lighter than you might expect for a machine that has travelled so impossibly far. Attached to the antenna support struts, in a position where it might theoretically be found by anyone who happened to encounter the spacecraft, is the famous plaque. It is small, about 6 inches by 9 inches, made of gold anodized aluminum, designed to resist the ravages of time and space for eons. On its surface are etched the figures of a man and a woman, rendered in simple lines standing in front of a silhouette of the spacecraft itself. The man's hand is raised in greeting, a gesture that might mean hello, or might mean peace, or might mean simply that humans are capable of reaching out, of communicating, of hoping to be understood. Beside the figures are symbols indicating the position of the Sun relative to 14 pulsars, a kind of cosmic map that might allow any finder to locate where we are in the galaxy, assuming they can understand pulsars and assuming they think the way we do about maps and positions and the desire to know where things come from. The plaque also contains a diagram of the hydrogen atom, the most common element in the universe, rendered in a way that might serve as a kind of Rosetta Stone for any intelligence that encountered it. The idea was that hydrogen is universal, that any civilization capable of space travel would understand its structure, and that from this common starting point, they might be able to decode the rest of the message. It was a beautiful thought, an optimistic thought, a thought that assumed the universe was full of minds that could be reached if only we tried hard enough to speak their language. But here is the tender truth about the plaque. It will almost certainly never be found. Pioneer 10 is travelling through a region of space so empty, so vast, so devoid of anything that might encounter it, that the odds of the plaque ever being seen by anyone are essentially zero. The spacecraft will coast for millions of years through the interstellar medium, passing through clouds of dust and gas so diffuse that a cubic mile of space might contain only a handful of atoms. It will drift past stars that are themselves separated by distances so immense that even at the speed of a light, it would take years to travel between them. And in all that time, in all that space, the probability that another spacecraft, another intelligence, another set of curious eyes will happen to encounter Pioneer 10 is so small that it approaches the impossible. Spare a thought too for the people who designed that plaque, who thought about what it should say and how it should say it, who debated the figures and the symbols and the arrangement of information on that small golden surface. Carl Sagan was one of them, the astronomer and writer who would later become famous for bringing the wonders of the cosmos into millions of living rooms. In 1972, he was younger, less well known, but already possessed of that remarkable gift for making the universe feel both vast and intimate, both terrifying and beautiful, both ancient and immediate. He worked with Frank Drake, the astronomer who had pioneered the search for extraterrestrial intelligence and who had created the famous Drake equation, that formula for estimating the number of civilizations in our galaxy. Together, they designed a message that tried to say everything important about humanity in the space of a few square inches of metal. Linda Saltzman Sagan, Carl's wife at the time, drew the figures of the man and woman, working to create images that would be comprehensible to an intelligence that had never seen a human being, that had no frame of reference for our faces or our bodies or our gestures. She drew and redrew, trying to find the balance between accuracy and simplicity, between detail and clarity, between showing what we look like and showing what we mean. The figures on the plaque are her work, her hand reaching across the gulf of space and time to greet whoever might someday find it. There were debates about the plaque, of course. Some thought the figures were too explicit, too revealing of human anatomy. Others thought they were not explicit enough, that they failed to capture the full range of human diversity. Some questioned whether the pulsar map was too precise, whether it might lead hostile aliens directly to our doorstep. Others questioned whether aliens would understand the map at all, whether our assumptions about universal knowledge were too narrow, too anthropocentric, too bound by our own ways of thinking. In the end, the plaque that flew was a compromise, an imperfect message from an imperfect species, a best effort rather than a perfect solution, and now it travels through the darkness, growing more distant every second, carrying those debates and compromises and hopes into a future that none of its designers will ever see. The plaque does not know that it was controversial. It does not know that some people thought it should be different. It simply is what it is, a small golden surface etched with symbols, riding on a spacecraft that will outlast every human being who ever argued about its design. Return with me, one more time, to the question of where Pioneer 10 is tonight. The answer requires us to think about space in ways that our minds were not evolved to comprehend. We are creatures of landscapes, of distances measured in steps and miles, of horizons that mark the edge of what we can see. When we think about space, we tend to imagine it as an extension of the familiar, as a larger version of the sky above us, as a place that works by the same rules as the world we know. But the interstellar medium, the space between the stars, is something different, something that resists our attempts to make it feel like home. Pioneer 10 is currently more than 12 billion miles from Earth. To say that number is to say almost nothing, because the human mind cannot truly grasp what 12 billion miles means. We can write it down, we can compare it to other distances, we can express it in terms of light hours or astronomical units, or any other measure we choose, but we cannot feel it, cannot sense it, cannot hold it in our minds the way we can hold the distance to the grocery store or the length of a highway we have driven. 12 billion miles is a number that defeats imagination. Let us try anyway. At 12 billion miles, the Sun is still the brightest object in Pioneer 10's sky, but only barely. From that distance, our star appears as a brilliant point of light, brighter than any other star but no longer recognisably a sun, no longer warm, no longer capable of illuminating anything or sustaining anything or providing any comfort to a machine that might still be dreaming of home. The Sun at that distance is simply another star, distinguished only by its brightness, stripped of all the qualities that make it ours. The temperature around Pioneer 10 is approximately 400 degrees below 0 Fahrenheit, so cold that most of the substances we encounter in daily life would become rigid, crystalline, inert. The spacecraft itself is chilled to temperatures that would destroy any living thing in moments, that would freeze the air in your lungs and the blood in your veins and the thoughts in your mind before you could even register the cold. But Pioneer 10 has no lungs, no blood, no thoughts. It simply endures, simply exists, simply moves through the darkness at a temperature that would terrify us, but means nothing to it. The radiation environment around the spacecraft is gentle now, almost peaceful compared to the searing bombardment it endured when it passed through Jupiter's radiation belts half a century ago. Out in the interstellar medium, there are cosmic rays, high-energy particles that have been travelling through the galaxy for millions of years, but they are sparse, scattered, nothing like the concentrated fury that Pioneer 10 survived when it ventured close to the giant planet. If the spacecraft's instruments were still functioning, they would record a calm, quiet environment, a region of space where not much happens and nothing hurries. And the view from Pioneer 10, if it could see, would be the most profound loneliness imaginable. There is nothing nearby. The nearest star, other than our own Sun, is light years away. The nearest planet is billions of miles behind. The nearest spacecraft, if we can even calculate such a thing, is Voyager 1, travelling in a completely different direction, separated from Pioneer 10 by distances that grow with every passing moment. Pioneer 10 is alone in a way that nothing on Earth has ever been alone, surrounded by an emptiness so complete that it makes the loneliest desert, the deepest ocean, the most remote mountaintop seem crowded and bustling by comparison. There is one more thing worth understanding about the space Pioneer 10 travels through, and it is perhaps the strangest thing of all. The interstellar medium is not quite empty. It is not the pure vacuum that we sometimes imagine when we think about space, not a perfect nothingness where nothing exists and nothing happens. Instead, it is filled with the thinnest possible trace of matter, a scattering of atoms and molecules so sparse that they barely qualify as present at all. In a typical cubic centimetre of interstellar space, you might find one atom or a tenth of an atom or even less. For comparison, a cubic centimetre of the air you are breathing right now contains roughly 25 billion molecules, a number so large that the word billion loses all meaning. This interstellar medium is composed mostly of hydrogen, the simplest and most abundant element in the universe, the same element that powers the stars and fills the vast clouds of gas where new solar systems are born. There are traces of other elements too, carbon and oxygen and nitrogen, and all the heavier atoms forged in the hearts of stars that died long ago. And there are dust grains, tiny particles of rock and ice and organic compounds, each one smaller than a speck of smoke, drifting through the void on journeys that began before our sun was born. Pioneer 10 moves through this thin medium like a fish swimming through the most diffuse possible fog, encountering one atom at a time, one dust grain per century, collecting nothing and affecting nothing, simply passing through on its way to somewhere else. The spacecraft is so small, and the medium is so sparse that the interactions are essentially negligible. Over millions of years, a few atoms might stick to the spacecraft's surface, a few dust grains might leave microscopic scars, but the fundamental nature of Pioneer 10 will remain unchanged. It will simply persist, simply endure, simply be. Picture, if you can, what the next 100 years holds for the spacecraft, and the 1,000 years after that, and the million years beyond. In 100 years, Pioneer 10 will have travelled roughly another 100 billion miles, a distance that sounds vast but that barely qualifies as significant on the scale of interstellar space. The spacecraft will still be in what astronomers call the local interstellar cloud, a relatively dense region of the interstellar medium that our own sun entered sometime in the past few thousand years. The cloud is warm by the standards of interstellar space, heated to temperatures of several thousand degrees by the radiation from nearby stars, but it is still so thin that Pioneer 10 will barely notice its presence. In 1,000 years, the spacecraft will have travelled roughly 1 trillion miles, and it will begin to approach the edge of what we might call our neighbourhood in the galaxy. The sun will have faded to a moderately bright star in Pioneer 10's sky, no longer dominant, no longer obviously ours, just one point of light among many. The constellations, as seen from the spacecraft, will have begun to shift, the familiar patterns of stars distorting, as Pioneer 10's changing position reveals new angles, new relationships, new perspectives on stars that we have known since the beginning of human history. In 10,000 years, Pioneer 10 will have left behind any trace of the solar system that most humans would recognize. The sun will be a dim star, barely distinguishable from hundreds of others of similar brightness, lost in a field of lights that offers no obvious way home. The spacecraft will be traveling through regions of space that no human eye has ever observed directly, through interstellar medium that we can only model and imagine, toward destinations that we can only calculate and never visit. And in 2 million years, give or take a few 100,000, Pioneer 10 will finally approach the vicinity of Aldebaran, that red giant star in the constellation Taurus, that ancient orange eye that has watched over human mythology since the earliest civilizations looked up and wondered what the lights in the sky might mean. Let us sit for a long moment with what that arrival will be like, even though no one will be there to witness it, even though the word arrival barely applies to a passage that will unfold across thousands of years at distances too vast for the spacecraft to notice. Aldebaran is not a single star. It is in fact a binary system, though the companion star is so faint and so distant from the primary that it plays almost no role in the system's dynamics. The primary star, the orange giant that we see from Earth, is about 44 times the diameter of our Sun, a swollen elderly star that has exhausted the hydrogen in its core and begun to fuse heavier elements, expanding outward as it enters the final chapters of its life. Aldebaran is roughly 6.5 billion years old, perhaps 1 billion years older than our own Sun, and it has already lived through stages of evolution that our star will not reach for another 5 billion years. When Pioneer 10 approaches this system, the spacecraft will pass by at a distance of about 3 light-years from the star itself, close enough to be in the same general neighbourhood, but far too distant for any meaningful interaction. At that distance, Aldebaran will appear as the brightest star in Pioneer 10's sky, brilliant and orange, perhaps 50 or 100 times brighter than any other star visible from the spacecraft's position. But it will still be just a star, just a point of light, offering no warmth, no illumination, no companionship to a machine that has long since ceased to need any of those things. And Pioneer 10 will not stop. It carries no engines capable of slowing it down, no systems that could adjust its trajectory, no intelligence that might choose to linger and observe. It will simply pass by, simply continue, simply coast onward toward whatever lies beyond, carrying its plaque and its message and its frozen instruments into a future that extends beyond any timeline we can meaningfully imagine. It is worth trying just once to feel the weight of that journey, to let it settle into your mind like a stone dropping into still water. Pioneer 10 has already been travelling for more than 50 years, and in that time it has covered a distance that seems almost impossibly vast, a journey that has taken it beyond every planet, beyond the edge of the solar wind, beyond the reach of any communication we can send. And yet that 50-year journey, that 12 billion mile voyage, represents less than 1/100th of 1% of the total distance it will travel before it reaches the vicinity of Aldebaran. Everything Pioneer 10 has done, everything it has seen, everything it has survived, every discovery it has made, and every signal it has sent, all of it together amounts to barely the first step of a journey that will continue for millions of years. The civilizations that built Pioneer 10 may be gone by the time it arrives at Aldebaran. The species that designed it may have evolved into something unrecognizable, or merged with machines, or spread across the galaxy, or faded into extinction. The sun itself will be different, larger and brighter as it begins its own slow transformation into a red giant, and Earth may be uninhabitable, its oceans boiled away, its atmosphere stripped, its surface scorched by the expanding star that once gave it life. Everything we know, everything we are, everything we have built and dreamed and hoped may have vanished by the time Pioneer 10 completes its journey. And yet the spacecraft will continue. It will not know what has happened behind it, will not mourn the loss of its makers, will not celebrate if they have thrived. It will simply be what it has always been, a small piece of metal and silicon and gold, moving through the darkness, carrying a message that may or may not ever be read, travelling toward a star that may or may not still shine when it arrives. There is a smaller, quieter story woven through all of this, and it concerns the people who kept faith with Pioneer 10 long, after most of the world had forgotten it existed. The mission was never supposed to last 30 years. When Pioneer 10 launched in 1972, its designers hoped it might survive for 2 years, maybe 3, long enough to reach Jupiter and return some useful data before the harsh radiation of space destroyed its delicate instruments. The fact that it continued functioning for more than 3 decades, that it kept sending signals from distances that had never been attempted, that it remained in contact with Earth long after every reasonable expectation had been exceeded, was a testament to both the quality of its construction and the dedication of the people who refused to let it go. The Deep Space Network, that collection of massive radio telescopes scattered around the world, kept listening to Pioneer 10 even as other missions demanded attention, even as newer and more sophisticated spacecraft launched and began their own journeys. The engineers who had worked on the mission in the 1970s grew older, retired, passed their knowledge to younger colleagues who had never seen Pioneer 10 launch, who knew it only as numbers on a screen and a faint signal in their headphones. And still they listened, still they tracked, still they maintained the vigil that connected Earth to its most distant emissary. The final team that heard Pioneer 10's last signal in 2003 was small, a handful of devoted engineers and scientists who understood that they were witnessing the end of something precious. They knew that the spacecraft would continue, that its journey was far from over, but they also knew that their part in that journey had come to a close. After 30 years of conversation, the dialogue was ending. After decades of signals sent and received, of commands transmitted and data returned, there would be only silence, and we cannot leave this story without acknowledging what that silence means, and what it does not mean. Silence is absence, but it is not emptiness. When we stop hearing from someone we love, when the calls stop coming and the letters stop arriving and the familiar voice fades from our lives, the person does not cease to exist. They continue somewhere, living their lives, experiencing their moments, being who they are regardless of whether we are there to witness it. The connection is broken, but the existence continues. Pioneer 10 exists tonight as surely as you exist, as surely as the stars exist, as surely as anything in the universe exists. It is not a memory or a hope or a dream. It is a physical object made of atoms that were forged in the hearts of ancient stars, assembled by human hands on a small blue world, launched into the sky on a pillar of fire and sent outward toward the infinite. Every second it moves another 27,000 miles farther from home. Every breath you take, it grows more distant. Every heartbeat, every blink, every passing moment of your life, Pioneer 10 continues its journey, indifferent to whether anyone remembers or cares or knows. And in that continuation, there is something that feels almost like comfort, almost like peace, almost like the quiet assurance that some things persist beyond our ability to perceive them, that existence does not require an audience, that the universe continues even when we turn away. Consider for a moment what it means to continue without witness. We spend so much of our lives seeking acknowledgement, craving recognition, hoping that someone somewhere sees us and knows that we are here. We document our days in photographs and messages and posts. We leave traces of ourselves wherever we go. We build monuments and write books and carve our names into trees, all in the hope that something of us will persist after we are gone, that the universe will remember we passed through. And yet Pioneer 10 continues tonight with no such hope, no such need, no such awareness that it is utterly alone in a darkness so complete that the word alone seems almost inadequate to describe it. It does not know that the signals have stopped. It does not wonder why no one is calling. It does not feel abandoned or forgotten or lost. It simply is, in the most pure and uncomplicated way that anything can be, a collection of atoms holding a particular shape, moving in a particular direction, carrying a particular cargo through the endless night. And there is something almost liberating in that simplicity, something that invites us to consider whether our own need for witness, our own hunger for acknowledgement, might be less essential than we imagine. The spacecraft weighs 570 pounds, give or take, depending on how precisely you want to measure. When it launched, it carried a full complement of instruments, 11 scientific experiments designed to study the interplanetary medium, to measure magnetic fields and solar wind and cosmic radiation, to take photographs and gather data, and send it all streaming back to Earth. Most of those instruments have long since fallen silent, their power exhausted, their sensors degraded, their useful lives concluded decades ago. But the mass remains. The structure persists. The golden plaque mounted on its side continues to reflect whatever faint light reaches it, the etched lines depicting a man and a woman still standing in their eternal greeting, the diagram of hydrogen still marking its fundamental frequency, the map of pulsars still pointing the way back to a small world in an unremarkable corner of an ordinary galaxy. It is worth pausing on the physical reality of that plaque, on the simple fact of its existence as an object in space. The gold anodized aluminum measures 6 inches by 9 inches, a rectangle slightly larger than a sheet of paper, mounted on the spacecraft's antenna support struts, where it would be protected from the micrometeorite erosion that might otherwise wear it away over time. The engraving is shallow, just a few thousandths of an inch deep, but in the vacuum of space, where there is no wind or rain or oxidation, those shallow lines will persist for longer than we can easily comprehend. The fingers of the man raised in greeting will remain extended. The smile suggested by the simple line of the woman's mouth will continue. The concentric circles marking the distances to the pulsars will keep pointing towards stars that are themselves slowly dying, their beacons fading over millions of years, their usefulness as navigational markers gradually diminishing as the cosmos continues its relentless evolution. But the plaque was never really meant for the aliens, if we're being honest with ourselves. The chance that it will ever be found, that some distant intelligence will intercept Pioneer 10 in the vastness of interstellar space and decode its message and understand what it represents, is so vanishingly small as to be essentially zero. The plaque was meant for us, for the people of Earth who needed to believe that their reaching out meant something, that their spacecraft carried not just instruments, but intention, not just mass, but meaning. It was a message in a bottle thrown into an ocean so vast that the bottle will likely drift forever without reaching any shore. And yet we threw it anyway, because that is what humans do, because hope does not require probability, because the act of reaching out matters even when no one is there to receive. Return with me, one more time, to that extraordinary day in March of 1972. The morning was cool at Cape Canaveral, the kind of early spring morning when the Florida air still carries a hint of winter, when the humidity has not yet risen to its summer oppressiveness, when the sky's clear and the stars are visible until the very moment of dawn. The Atlas Centaur rocket stood on the launch pad, its white body gleaming in the floodlights, its payload shrouded at the top, waiting for the moment when it would transform from a stationary object into a moving one, from potential into kinetic, from hope into reality. The countdown proceeded through the night. the hundreds of engineers and technicians monitoring their stations, checking their readouts, confirming that every system was functioning within acceptable parameters. Pioneer 10 sat at the top of the stack, 570 pounds of human ingenuity packed into a hexagonal frame 9 feet across, its dish antenna folded, its instruments dormant, its golden plaque hidden beneath the protective shroud that would fall away once it reached the vacuum of space. In a few hours, it would be travelling faster than any human-made object had ever travelled. In a few days, it would cross the orbit of the Moon. In a few months, it would be farther from the Sun than any spacecraft had ever been. And in a few decades, it would be so far from home that the very concept of distance would need to be reconsidered. Picture, if you can, the faces of the people gathered in the control room that morning. Some of them were young, just starting their careers, filled with the boundless optimism of people who believe that anything is possible if you work hard enough and dream big enough. Some of them were veterans, scarred by failures and near misses, carrying the weight of missions that had ended in silence and fire and disappointment. All of them were tired, the kind of bone-deep exhaustion that comes from weeks of preparation and nights of worry, from the knowledge that years of work would be judged in the next few minutes, that success and failure hung in the balance of 1,000 things that could go wrong. And all of them believed, despite everything they knew about the cruelty of space and the fragility of machines, that this mission would succeed, that Pioneer 10 would reach Jupiter and send back its photographs and reveal secrets that had been hidden since the formation of the solar system. The engines ignited at 8:49 p.m. Eastern Time on March 2, 1972, and the rocket rose into the Florida night on a column of fire that turned the darkness into day. The sound reached the observers a moment later, that deep, rumbling roar that you feel in your chest more than hear with your ears, that visceral confirmation that tremendous energies are being unleashed, that tons of fuel are being converted into thrust, that gravity itself is being defied by human will and human engineering. The rocket climbed, tilted, accelerated, its stages separating and falling away as it shed the weight it no longer needed, its velocity building toward the 32,000 miles per hour that would carry Pioneer 10 beyond the reach of Earth's gravity forever. And then it was gone, a point of light diminishing into the star-scattered sky, and the people in the control room began the long process of tracking and monitoring and waiting that would consume the next 3 decades of their lives. They could not have known, standing there in the afterglow of launch, that they were beginning a relationship that would last longer than many marriages, that they would still be listening for Pioneer's voice when their hair had turned grey and their children had grown and their world had changed beyond recognition. They could not have known that the tiny spacecraft climbing into the darkness would outlive some of them, would continue its journey long after they had departed this world, would still be coasting toward the stars when their grandchildren were born and grew old and passed away in their turn. Spare a thought, too, for the spacecraft itself in those early days, when everything was new and everything was working and the universe was opening before it like a flower. The instruments came online one by one, their sensors tasting the solar wind for the first time, their cameras calibrating against the known positions of stars, their magnetometers measuring the invisible fields that wrap around our sun like the lines of force around a magnet. Pioneer 10 was, in those early months, gloriously alive in every way that a machine can be alive, fulfilling every function it was designed to fulfill, exceeding every expectation its creators had set for it. It crossed the orbit of Mars in early July, entering the asteroid belt that had haunted the dreams of mission planners for years. No one knew, not really, whether a spacecraft could survive the passage through that field of ancient stone, whether the accumulated debris of the solar system's formation would batter Pioneer 10 to pieces before it ever reached Jupiter. The asteroid belt turned out to be far less dangerous than feared. The distances between objects so vast that the chance of collision was vanishingly small, the feared gauntlet revealing itself to be more like an empty highway than a shooting gallery. Pioneer 10 passed through unscathed, its instruments recording data about the composition and distribution of dust particles, its cameras photographing the void, its antenna sending a steady stream of information back to the listening ears on Earth. And then, in December of 1973, came Jupiter. Let us sit for a long moment with that encounter, with the first close approach to the largest planet in our solar system. Pioneer 10 passed within 81,000 miles of Jupiter's cloud tops, close enough to see the individual storms swirling in the atmosphere, close enough to feel the tug of a gravity so powerful that it could have captured the spacecraft forever, close enough to risk everything on the accuracy of calculations made years before on primitive computers. The photographs it sent back were revelations, images of a world more beautiful and more terrifying than anyone had imagined. Bands of colour wrapping around a sphere that could swallow Earth 1,000 times over. The Great Red Spot revealed as a storm larger than 3 Earths side by side, a hurricane that had been raging for centuries and showed no sign of stopping. But the photographs were almost secondary to the scientific data, to the measurements of Jupiter's magnetic field and radiation belts, to the detection of plasma streams and charged particles, to the mapping of the gravitational field that would guide all future missions to the outer planets. Pioneer 10 proved that spacecraft could survive the radiation environment around Jupiter, that the giant planet would not destroy the machines we sent to study it, that the outer solar system was not forever closed to human exploration. Every mission that followed, every Voyager and Galileo and Juno, owed its existence to the little spacecraft that went first and proved that the journey was possible. It is worth trying, just once, to feel the magnitude of that gift. Pioneer 10 gave us Jupiter, not in the sense of ownership, but in the sense of knowledge, of understanding, of the intimate familiarity that comes from seeing something with your own eyes rather than imagining it from afar. Before Pioneer 10, Jupiter was a point of light in the night sky, a wandering star that ancient astronomers had tracked across the zodiac, a disk in early telescopes that revealed bands and spots, but no real detail. After Pioneer 10, Jupiter was a world, a place, a destination that we had visited and photographed and studied and known. The transformation was as profound as the moment when humanity first saw Earth from space, first understood our planet as a sphere hanging in the void rather than a flat surface stretching to every horizon. Pioneer 10 expanded our understanding of home by showing us what lay beyond it, and then it continued outward, its primary mission complete, its bonus mission beginning. It crossed the orbit of Saturn in 1976, though its trajectory took it nowhere near the ringed planet itself. It crossed the orbit of Uranus in 1979, Neptune in 1983, and in 1983 it also crossed a symbolic boundary that meant nothing to the spacecraft but everything to the people who were watching. The orbit of Pluto, making Pioneer 10 the first human artifact to travel beyond all the known planets, the first object to leave the classical solar system behind. There is one more thing worth understanding about the nature of Pioneer 10's journey, about the way space itself changes as you move farther from the Sun. We tend to think of the solar system as a series of concentric circles, planets orbiting at various distances like the rings of a target, with the Sun at the centre and empty space filling the gaps between. But the solar system is not empty. It is filled with the solar wind, that constant outward flow of charged particles streaming from the Sun's corona at hundreds of miles per second, and that wind creates a bubble, a vast sphere of influence called the heliosphere, within which the Sun's presence is felt and beyond which interstellar space begins. Pioneer 10 was heading toward the edge of that bubble, toward the boundary where the solar wind finally loses its momentum and gives way to the thin gas and cosmic radiation of interstellar space. It would take decades to reach that boundary, decades of silent coasting through the thinning wind, decades of moving farther from everything familiar while the Sun shrank to a point and the familiar constellations remained stubbornly unchanged. The spacecraft was traversing distances so vast that human intuition simply fails to comprehend them. Distances measured not in miles or even in millions of miles, but in the time it takes light itself to cross them. Consider for a moment the silence that surrounds Pioneer 10 tonight. The solar wind has thinned to almost nothing at the distance it has reached. The occasional dust particle drifts by, remnant of some ancient collision, but the intervals between such encounters stretch into years and decades and centuries. The temperature is barely above absolute zero, cold enough that any gas would freeze solid, cold enough that molecular motion nearly ceases, cold enough that the very concept of warmth becomes theoretical rather than physical. And in that cold, in that darkness, in that perfect silence, Pioneer 10 continues. The spacecraft does not dream. It does not remember. It does not anticipate. It simply persists, atom by atom, structure by structure, the nuclear power source long since exhausted, but the mass still intact, the golden plaque still attached, the dish antenna still pointing in the direction that was once toward Earth but is now toward a star that Pioneer will not reach for millions of years. It is the purest form of continuation imaginable, existence stripped of everything except existence itself, being without awareness, presence without perception. And in that purity, there is something that feels almost sacred. We have spent so much time in this story talking about what Pioneer 10 cannot do, cannot feel, cannot know. We have acknowledged, honestly and directly, that the spacecraft will never reach Aldebaran, that the plaque will almost certainly never be found, that the message will never be read, that the journey has no destination in any meaningful sense. We have faced the melancholy of these truths without flinching, without pretending that hope is the same as probability, or that wishes can bend the laws of physics. But now, as we approach the end of our time together tonight, it is worth considering what remains when all those impossibilities are acknowledged, what Pioneer 10 still represents, even when stripped of the fantasies we might want to project onto it. It represents the fact that we tried. That is not a small thing. In a universe that did not ask for our presence, and does not notice our existence on a planet that will forget us as thoroughly as it forgot the dinosaurs, during lives that are over almost as soon as they begin, we looked up at the stars and decided to send something. We took our limited resources and our limited time and our limited understanding, and we built a machine capable of escaping our gravity well, of surviving the radiation belts of Jupiter, of crossing distances that make our entire civilization look like a momentary flash in an infinite darkness. We attached a message, knowing it would probably never be read, because the act of sending matters even when no one is there to receive. Pioneer 10 is proof that we are the kind of creatures who do such things. It is evidence, physical evidence, travelling evidence, that among all the species that have ever lived on this world, among all the experiments evolution has tried over billions of years, one of them produced beings who dream of the stars and build the tools to reach them. The spacecraft is small, 500 pounds of aluminum and electronics drifting through an ocean of emptiness that stretches for light years in every direction. But it carries with it the weight of everything we have ever hoped and wondered and imagined about our place in the cosmos. Tonight, as you rest, Pioneer 10 continues its journey. It has travelled more than 15 billion miles from Earth now, a distance so great that if you tried to walk it, stepping one foot in front of the other without rest or pause, it would take you more than 500 million years to arrive where the spacecraft is tonight. And by the time you arrived, Pioneer 10 would have moved another 500 million years worth of distance farther on, forever receding, forever beyond reach, forever carrying its cargo of human hope into the infinite dark. But it is not gone. That is the thing that matters, the thing that deserves to be said clearly and without qualification. Pioneer 10 is not a memory or a metaphor or a lesson from history. It is a real object in the real universe, made of real atoms, occupying a real point in space, moving at a real velocity in a real direction. At this very moment, as you listen to these words, it is crossing another few thousand miles of the void. In the time it takes your heart to beat once, it has travelled another 8 miles. In the time it takes you to draw a single breath, it has moved nearly a quarter mile farther from everything you have ever known. Silence is not the same as gone. This is the truth that Pioneer 10 teaches us, the consolation it offers to anyone willing to receive it. We stop hearing from the people we love and we grieve the silence, and we wonder if the connection was ever real. We lose touch with the dreams we once had, and we tell ourselves they were childish fantasies, and we pretend that the forgetting doesn't hurt. We watch the years pass and the world change and the certainties of our youth dissolve into the ambiguities of age, and we start to believe that nothing persists, that everything fades, that silence is the only destination any journey can have. But Pioneer 10 continues tonight, as it continued last night, as it will continue tomorrow and the day after and the year after and the millennium after that. It will still be crossing the void when the pyramids have crumbled to dust and the continents have drifted into unrecognisable configurations, and the sun has swollen and dimmed and died. It will still be carrying its golden plaque, still bearing its portrait of a man and a woman in eternal greeting, still pointing back toward a world that no longer exists except as a memory encoded in metal, travelling toward infinity. And in that continuation, in that quiet persistence beyond all witness and all memory, there is something that feels like hope, something that feels like peace, something that feels like the universe acknowledging just once that that we were here, and that we tried, and that trying matters. Pioneer 10 is still out there tonight, coasting silently through the dark, growing more distant with every breath you take. It already gave us the one thing we most needed. Not the grandeur of Jupiter or the mystery of interstellar space, but the knowledge that we are the kind of beings who send messages even when no one is listening, who reach out even when no one is there to receive, who continue hoping even when hope is irrational. Silence is not the same as gone, and the fact that we sent Pioneer 10 at all proves something about us that is worth knowing, worth remembering, worth carrying into our own sleep. Thank you for travelling out to the very edge of everything with me tonight. The stars will still be there when you wake, and somewhere among them, beyond sight and beyond hearing, but not beyond existence, a small spacecraft continues its journey, patient and faithful and forever. Keep looking up, take good care of one another, and good night.